Okay, testing. I'm just gonna make sure that the audio and everything is working because I don't want to mess that up. Okay, I can't hear myself on my phone, I think. Okay, yeah, it's good now. Perfect. Okay, so this is the main setup. The questions are going to be here. Right now we're at 918, so we'll stop when we get to 1018. So that's how I'm going to measure it because I'm not going to like actually count through each question. The stopwatch is over here, so I'll just make sure that I might take breaks. It's probably not going to be one contiguous 3-hour block. There'll be a few breaks here and there, and then the work and everything will be over here. It's a pretty big whiteboard. Like some of the space is still, a lot of the space has been taken up, but like I can fit questions in this little space, so um, it shouldn't be an issue, and we can always make more room if we need. So that's how we're going to do it. In terms of what I'm actually going to study, I don't know. Like obviously, I actually haven't used Alcumus in a long time. I might also switch out from Alcumus and do something else in the middle. I'll have to see. But most likely it'll be like a lot of Alchemist. It might be the math counts trainer and the other things that AOPS has over here. Uh, yeah, like for the win, I won't count for the win because those are much easier questions. But we might do that. We might also do. Um, I don't think I've ever tried practice contests here before, but we can also do like previous year questions from other places. Like I have AMC trainer and trivial math practice, which can also give more questions. Anyway, we won't begin with that though. We'll begin over here. So this is the first question. If BAE is 43 degrees, find CED. If Okay, so because BC and CE are both tangents, BC is equal to CE because you're going from the same point. And so if BAE is 43, first we know that ABE is also going to be 43. Yeah, and if that's the case, then EBC, okay, I should draw this out a little so that I can be more clear. I just dropped my charger. Give me 1 second. Okay, so this is what it looks like. It's a circle, so this is going to be equal to this, and then we have this. These are both tangents, so these are also going to be equal, and then this just continues down like so. If this angle here is 43, okay, this is a very thick pen, so it's kind of difficult. If this angle here is 43 degrees, then this angle is also 43. This entire thing is a right angle because it's a tangent line, right? And so this is going to be 47 and this is going to be 47. So what is CED? That's a little trickier. So this is 43, this is 43. So what is this angle going to be? It's going to be 180 minus 2 times 43. So that'll be 94. So now this angle plus this angle here, I want to draw it better in the future so that you can see clearly. Right now the pen is very thick, but this is the minimum it is because I've zoomed in so much over here. But anyway, so 94 plus 47 plus the measure of CED is going to be equal to 180 degrees, and so that will be 86 minus 47, I believe. Yeah, yeah, 86 minus 47, which is what, 39? Okay, no, that's wrong. CED. That is what they're asking for. Let's see. I've calculated something wrong here, I think. Oh, it's 86. Um, and so it'll be, Yeah, no, the 94 part makes sense. 86. Did I do this math here correctly? 47 and 47, find CED. If BAE is 43, then ABE is also. I'll just draw it bigger now, like this. Yeah, let's just be very clear with everything. So that's 43, right? BAE. This is also 43. Then what does this have to be? This has to be 180 minus 86, which is 94. And then it goes like this. So this is straight. And this is right here. So these angles are also going to be equal. For the reason that, one sec, wait, CED. So that's this one. I'm not sure what the mistake is. So this should be 47 again, right? Because these are up to 90, 80 plus that, yeah. So this is also going to be the same because they're two tangents and these lengths are then equal. Right, isosceles triangles are pretty important here, but I'm not sure. So if this is 47, now what do these add up to? They add up to 131, sorry, 141, which leaves us with 39 degrees. So CED should be 39 again. Okay, wait. Unless I've done something really stupid in the calculations here, I don't see why it's wrong necessarily. Um, hmm. And CED that I'm looking at here is also it's the correct angle, like it's not the wrong angle that I'm doing. If you have any like suggestions, let me know in the chat because I'm not sure what I've done wrong here. Maybe I can like label things and see in case there's any like dumb mistake that I made there. And yeah, I mean I think the definitions are fine too. Let E be a point of the circle and at the tangent. So OA and OB are both radii. I guess BE does not necessarily have to be the same actually. That's my mistake, I think. Yeah, okay, so obviously that should be the mistake then, I guess. So I have to work, like kind of undo this stuff here. Yeah, I mean, that's the only thing I can think of. And actually, to be fair, there was no reason for me to assume that. It was kind of just an assumption. But I can try to fix this. So this is 90 degrees over here. So this over here will be 47. Because this is 47. Okay, now there's a formula for that. Um, what is the formula though? I'm kind of forgetting now. So okay, yeah, so the entire point is that there are angles and circles and there's certain relationships there, but I'm just forgetting what they are at this time. So let me try to see. I mean, it's not like I want to be able to derive anything here, but maybe I can like, just draw something with the radius and see if I can figure out anything from there. So Why did they give us BE? There must be some sort of reason for that, right? Otherwise, they wouldn't have uh, given that. So I think that definitely has something to do here. Something to do with what we're working with here. I don't think like unless I can figure out what the relationship is, I'm not going to be able to. Um, oh, I haven't started the timer either. Okay, let me do that now. I'll take out some time later on. I think it's been like 5 minutes. Let E be a point of the circle and let the tangent B intersect the tangent at E and AE. So okay, I mean I can think of this. This is going to end up being twice as much. Okay, wait, yeah, maybe that's it. OE is going to have, so BOE, that angle is going to be twice as much as OAE. So this is going to be 86. And now OE is the same as OB because they're both radii. So what are we left with? Left with 94 degrees divided by 2. So this should be 47. This should be 47, but that's besides the point because if this is 47, this over here is going to be what? It's going to be 43. And so if that's 43, then this has to be 43 as well. What are we asked to find? Okay, there are enough ways to go about this now. I think the easiest is probably this is going to be 86 because it's 180. This is 180 minus 43 minus 43. So if that's 86 and that's 47, what do those add up to? They add up to 133, and so we need 47 more degrees. So it should be 47. Okay. Yeah, I think that's just what I was forgetting, right? Let's see, what did I do wrong? CBE, BAD, and CBE subtend arc BE. Okay, so that's just a different way of going about doing it then. I see. Yeah, that was my bad. Circle gamma is the incircle of triangle AB and is also the circle of triangle XYZ. So if it's the incircle of a triangle, it's going to be inside that. So let's just draw the circle first. This is gamma. So there's a triangle that will fit completely inside this. The point X is on BC. So it's the incircle of BC. So that'll look something like this maybe. Yeah, not my best drawing, but that'll do. Yeah, it's actually really bad. Let me do this a little bit better. Okay, so that's the first one. It's not a right triangle, even though it kind of looks like that, I guess. That's not the case. Okay, so the point X is on BC. So let's label these off, A, B, and C. A is 40 degrees, B is 60 degrees, and C is 80. Okay, so I've kind of messed it up. We don't need to make it that bad though. We can just say this is C, which is 80 degrees. This is B, which is 60 degrees. And then this is A, which is 40 degrees. Okay, so I think that fixes the main issue that we had. Yeah, okay, let's go with this. The point X is on BC, so this is BC, so this point here is going to be X. The point Y is on AB, and then I guess this one is Z. Okay, what is the measure of Y, ZX? Y, ZX. Okay, so let's draw the center of the circle. We can call that gamma because that's the center. What about, it's also the circle of triangle XYZ. Oh, okay, so this is XYZ, that makes sense. I think there's a relationship where these two triangles might be so triangle XZY might have to be similar to, I don't know in what order, but it might be similar to ACE ABC. I don't know if that's not necessarily the case though, and I don't think I can prove it over here. So instead, let's just think it through logically using the center gamma. So from the center, this is going to be a right angle because it's a radius. This one's drawn badly, but yeah, I mean, this is also a right triangle, just doesn't look like it. So this is a right triangle, and this is what we have here. We can, yeah, I mean, we can find the angles now, can't we? So this is also going to be a right triangle. Because this angle over here is 60 degrees, this is going to have to be 120. I'm going to put this in a different color, like this. So this is 120 degrees. What is this going to be? It's going to be 140 degrees. And then this one's going to be 100 degrees, which adds up perfectly to 360, like we want. If that's the case, what is this going to be? This angle over here is just going to be 20 degrees because it's 180 minus 140 over 2. This angle over here is going to be 40 degrees. Oh, okay. Well, yeah. So the answer should be 60, I think. I'm gonna just, does that make sense? It does. It seems right. And actually, if that's the case, then I think this is also going to be 40. This is going to be 30. And if this is 30 and this is 20, this is going to be 50. So we've got 50, 60, and 70. Yeah. So I mean, it's not the case then that they match up with this. So 60 seems right. And I think okay, they use a different approach. Or no, but I mean, they used largely the same approach. So yeah, not too bad. Let's continue. Find the angle alpha in degrees. It's a hexagon inscribed in a circle. In a circle. I think the first step would be to just like draw triangles within this and see what you can do from there. So let's go and do that. That's a circle, and then the hexagon with, it's not a regular hexagon, of course, because the angles aren't all 120. So I'll just draw 6 random sides. 3, 4, 5, 6. Perfect. 110. Skip this one. This one is 105. So if we draw this one over here, what do these angles add up to? If we draw this one over here, what do these angles add up to? Oops. And if we draw this last one over here, what do these angles add up to? And then we know that, of course, there's a triangle in the middle as well. So we've broken it up now into 4 triangles. Let's start to kind of annotate them. Right, so we should probably name them, right? So obviously this one is alpha. This is what we want to find. And before we find that, we need to figure out some other stuff. So let's see what that other stuff is. There's no like, really special information that we have here, I think. But we know that this shape over here, the one whose vertices I'm making now, this one, that's going to be a quadrilateral. So the angle within that, the sum of the angles is going to be 180. So let's give these names, right? So this is going to be X. Let's call this Y. Let's call this Z. Okay, I mean, this doesn't really help us to be fair. Actually, I don't think any of this is going to help us much, but that's fine. One thing that we can do is maybe switch the way we've drawn the triangles or get rid of some of the stuff entirely. But okay, so like from this, of course, x plus y plus z is 180. And I was thinking we could come up with some algebraic relationships here, but like if we call this um, a and b, a plus b plus alpha is 180, and then when you add them all together, you're going to get the same thing. X plus y plus z plus a plus b plus alpha is 360, which doesn't help at all. So I don't think that's the right way to go. Maybe we can still keep what we have here. But because it's a circle, we should probably draw a circle. We should probably draw the center of the circle and then see what we can do from there. So let's draw that. And I mean, we should probably connect this to some of the vertices, maybe not all of them, because that might just make it a bit too cluttered. But let's draw a few that seem relevant. So this one is probably useful. The reason for that is that um, well, that's not okay. Wait. Yeah, I mean, so this is going to be 2x then, isn't it? This is 2x. And so if we continue like that, what can we get? There should be some other relationships that we can come across, that we can come up with. And I think, okay, then won't, I mean, thinking through that, um, this entire thing here should be 2 alpha, right? Just using the same logic. And that tells us that 2x plus 2 alpha is 360. So alpha plus x is equal to 180. That means that alpha, right, is equal to, let me see if you guys can actually see that. Okay, I mean, I think it's getting somewhat blocked for you. So let me get rid of this then. I'll just scroll. So that means that alpha is equal to z plus y. How does that help us? Well, if that's the case, I mean, that means that z plus y are both, that they are to 180 degrees as well. And so I think this is cyclic. And actually, by using the same logic, you can probably figure out that all of these angles are actually cyclic, meaning that if x and alpha are, okay, wait, we have two angles, right? We have 110 and we have 105. So let's just, yeah, I mean, from that we can figure out what y is. This is 110, y should be 70, but that's not going to help us. Okay, so maybe the 105 will help us. What quadrilateral can we make with that? Oh wait, no, sorry, that does help us. Never mind. I don't know what I was doing. Z is equal to sorry about that. Z is equal to 75. Never mind. I forgot. So y plus z is not equal to 180 like I was thinking. Y plus z plus this would give you 180, but y plus z are not themselves that. Remember, alpha is equal to the sum of those two, so alpha is going to be 145. Yeah, that took a lot longer than it should have. Sorry about that. Let's see, one more. A triangle with side lengths in the ratio 3, 4, 5 is inscribed in a circle of radius 3. So let's draw the triangle first. And actually, wait, if it's inscribed in a circle of radius 3, what is the area of the triangle? I mean, okay, I know how to do this, I think. Because it's inscribed like this, if the radius of the circle is 3, the diameter is going to be 6, and that will end up being the hypotenuse. So this is 6. So it'll be 3/5 of 6, so this will be 18/5, and this will be 4/5 of 6, which is 24 over 5. So the area of this is going to be 18 times 24 over 25 times 1/2, which is 9 times 24 over 25. They want us to round to the nearest hundredth, so we're going to make that 36 times 24 over 100, which is 30 plus 6 times 30 minus 6 over 100, which is 30 squared minus 6 squared over 100, That's 900, so 9.64. Okay. Oh, sorry, 864. 8.64. My bad there. That's correct. Yeah. Stupid mistake, but yeah, I mean, that's it. 216 over that. Let's see, one more. We're at 6 out of 7 right now. A circle is centered at O. Okay, so that's the center. Let me zoom in a little bit so I save space. So this is the center over here. Okay, even worse. AB is the diameter of the circle, so let's just draw that through the center over here. And C is the point of the circle with COB equaling 50. So that's like roughly here, let's say. Okay, that looks good. What is the degree measure of CAB? Oh, that'll just be half of that, right? That'll be 25. Yeah, I mean, there's a formula for that. I just forgot what it is. I mean, yeah, okay, that is easy. So I'm just going to clear up some space on this side of the board so we don't waste more. Let P be a point outside of circle O. So this is going to be a circle O. P is like over here, let's say an arbitrary point. A segment is run from P such that it is tangent to the circle O at point T. So just like that. We'll call that T over there. Meanwhile, a secant from P intersects O at A and B such that PA is less than PB. So A is like on the closer side, like so. This is A, this is B. There are only a few formulas here that I think this is power of a point. If PA equals 3 and PT equals AB minus PA, then what is PB? Okay, so this is we can call AB X, right? And now AB minus PA is just X minus 3. And what power of a point tells us is that X minus 3. So wait, let me zoom out a little now. Okay, let me see. Did I set this up correctly? Yeah. And they're asking us for PB. So basically, they're asking us to find 3 plus X. Um, yeah. Okay, that should be fine. So 3 times 3 plus X from power of a point, that's PA times PB, is going to be equal to PT times PT. So that's X minus 3 squared. That's 9 plus 3X equals X squared minus 6X plus 9. So X squared minus 9X is equal to 0. Right? And so X is going to have to equal 9. So X plus 3, which is what we were asked to find, is going to be 12. Yep. Okay. So, I mean, obviously the drawing is not to scale, but that's fine. Let's see this one. Two triangles, ABC and ACD are drawn. What is the number of square units in the area of the fourth square? Okay. So, I mean, AC is going to be, if AC were a square, it would have 45. So it's 45 plus 16, which is 61. It's just that. It's just like the Pythagorean theorem, I think. Let A, B, C, and D be points on a circle such that AB equals 11 and CD equals 19. So let's draw out a circle over here again. Oh, we're in lengths in circles, so that's why there's so many of these. Let's use a nice, fresh color. Let's do pink this time. Such that AB is equal to 11, so this is the center, and CD equals 19. Point P is on segment. Okay, let's just draw it out. So 11, and then the other one is 19. So 19 should be a little longer than that. The line through P and Q. Okay, so A and B, this is going to be 11, and then CD is 19. I don't think they're supposed to intersect. Maybe they can. Point P is on segment AB with AP equals 6. So that's going to be like right there. Like right here. This is going to be 5 then. And Q is on segment CD with CQ equals 7. So that's right here. This is 12. The line through P, okay, this is Q. The line through P and Q intersects the circle at X and Y. If PQ equals 27, find XY. Doesn't have to pass through the circle, but through the center, but just ignore that for now. Find x, y. So this is x and this is what, y. So I mean those are uppercase x, uppercase y, and then this distance PQ is 27, right? So okay, I mean let's call this x, and then this is y. And what we're going to do here is use the power of a point, or whatever the chord formulas, twice. So when we use AB and x, so APB XPY, that gives us x times 27 plus y is equal to 30, right? And then from the other one, so when we're doing it with CQD and XQY, we get 7 times 12. So y times 27, 27 plus x is equal to 84. And what are they asking us for? They're going to ask us for the total length, x plus y plus 27. So let's say distribute over here. We get 27x, and I think I know where this is going. Actually, wait, I mean, we can probably do this in our head. Um, yeah, that'll be good practice as well. So when you expand the two of these, you're going to get x, y in common, and then 27y and 27x. No, wait, actually, no, that seems wrong. So 27x plus xy is equal to 30, and then 27y plus xy is equal to 84. You can subtract them, but then when you subtract them, that kind of makes it troublesome, doesn't it? In the sense that now you get y minus x equaling something. So I think y minus x is equal to 2 from this. And that doesn't really help us, does it? I mean, okay, okay, now we can put this in somewhere and then see. So y is going to be equal to x plus 2. And now we can put this into either of the equations and see. I think it's easier to put in the second equation. So x plus 2 times 27 plus x. Because we can't find x plus y, which is what we need, right? So we can't find that yet. This is equal to 84. Let's guess and check with some nice easy values because I think it won't be too bad. What about like, what are the factors of 84? 7 times 12. Oh, 28 times 3. So yeah, I mean, x equals 1 works then, doesn't it? That's 3 times that. Yeah, so I mean, if x is 1, then y is 3. And then x plus y is 4. 4 plus 27, 31. And I think that makes sense as well, right? Yeah, so it's just like a very, you have to use two of the equations, subtract them, and then figure it out from there. That wasn't, I enjoyed that question, I think. The solid shown consists of three, this is on prisms. What is the surface area of the figure in square centimeters? So this shouldn't be too bad again. What we're going to have is the, wait, they're all cubes. So the faces like this face, and then the one back here and all the way back there. There are going to be four of them. Those are going to be visible for each of the prisms. So it's going to be 3 times 3, which is 9, 2 times 2, which is 4, and 1 times 1, which is 1. Those are each going to be shown 4 times. So that gives you 36, 16, and 4. Add all of these up. And then what else do we have? Well, we have the top um, for 1 and 2 and 3, right? Part of the top, the entire top for 1, a little bit of the top of 2, a little bit of the top of 3, and then all of the bottom of, wait, yeah, and then all of the bottom of 3. I think they're counting that as well. So first of all, let's add these up, right? This gives us, I think, 56. The top of 1 is going to be 1. This is going to be 3 because it's 2 squared minus 1. And then this is going to be 5 because it's 3 squared minus 4 squared, right? And so that's 5. And then the bottom is going to be 9 more. So let's add these up smartly. 64 plus 10, 74. Hope I didn't, yeah, I don't think I messed that up. 74 should be the answer. Square centimeters, yeah, I mean the units are fine there. Okay, correct. Regular hexagon ABCDEF is a base of right pyramid PABCDEF. Okay, so it's basically just a hexagon, and then you're kind of you're pinching it and pulling it. Okay, I'm explaining it badly. Let me just try to draw it out. So it's a regular hexagon on the bottom, which would look like this. And then there's a point over here, so just going up from all directions. And that's what it means by right pyramid. If PAD is an equilateral triangle with side length 6, so what would PAD look like? This will be A, B, C, D, E, F. If this is the case, if we have PAD being an equilateral triangle with side length 6, what is the sum of the lengths of the edges of the pyramid? I mean, okay, this isn't too difficult because this point over here is P. If PAD is an equilateral thing, PA and PD are all going to be 6. Also, because it's symmetric, so I'm going to use different colors now. Let's call this P. Because it's symmetric, this is going to be 6, this is going to be 6, all of them are going to be 6, and there's 6 of them. So that's 6 times 6, which is 36. Now we have to find the side length. How do we find the side length? Well, just draw the regular hexagon again. What is this length? I'm pretty sure that length is twice the uh, twice this. So this is 6 and these will all be 3. And yeah, I mean that checks out. So it's going to be 3, 3, 3. 3 times 6, which is 18. 18 plus 36, 54. Yeah, okay, so I think that's probably the solution as well. Yeah, 36 plus 6 times 3. Perfect. Okay, I mean exact same thing. Literally the exact same question with a different number, right? Equilateral triangle side length 8. In fact, we can just instead of 3, this is going to be 4, so this is going to be 24. It's just going to be 4 thirds times 54, so that's 72. Exact same logic. Okay, wait. Did I do this wrong? 8 times 6, what is 8 times 6? That's 48. PABCDEF. If PAD is an equilateral triangle with side length 8, so this is 8, that's 8. This is going to be 4. 4 times 6 is 24. Oh, what is the volume of the pyramid? Okay, yeah, I mean, that's a stupid mistake on my part. It's not that bad though, because the volume formula isn't super difficult. What we need to know here is that, so basically, the height is going to be 4 root 3. And there's a reason for this. The reason is that if you like, this is the height, and you're going to continue like this, right? So this over here is P, this is A, and then if you were to continue this, you'd get D on this side. You know that P is, this is 8, this entire thing is 8 as well. But because it's symmetric, this half distance here is going to be 4. This is, it doesn't look orthogonal, but it should be because it's, it's normal to that. This is a right angle, and so by the Pythagorean theorem, this is 4 root 3. The area of the bottom is just given by s squared root 3 over 4. S over here isn't that just 4? It is 4. So that's 4 root 3 times 4 root 3 over 3. Right? It's the area of the base, which is going to be just 4 root 3 times the height, which is 4 root 3 divided by 3, which is just going to give you 16 in the end. Okay, wait. Oh no, that's for an equilateral triangle, so it should be 6 times as much. So 96. Yeah, okay, a very dumb mistake there. The This is for an equilateral triangle, not for a hexagon. A hexagon is 3 halves s squared root 3. And so, like, yeah, I mean, that would be 24 root 3 times 4 root 3 over 3. The root 3, and 1 over 3 would cancel out and give 96. Very dumb mistake there. My fault there, completely. Okay, let's try this. So, if it's a rectangular prism, if the volume of pyramid ABCH, so what is pyramid ABCH? What would that look like? Yeah, I mean the so ABCH would look something like this, right? And then the height of the pyramid, it does like once you pull up that height, you can drag it around anywhere, but all that matters is the surface area times the height over 3. What we know the volume is 120, right? AH, what would AH itself be over here? Um, oh, sorry. AH over 3. We're defining A as the area of this. What would this entire thing be? That would be 2A. What would this height be that we're going to be multiplying it by? That would just remain H, right? And so 2AH is going to be the volume of A, B, C, D, E, F, G, H. So it's just going to be this times 6. So that's 20 times 6, which is 120. Yeah, okay. Two cross sections of a right hexagonal pyramid. So we've seen a lot of those already. Are obtained by cutting across pyramid with planes parallel to the hexagonal base. The areas of the two things are okay. The areas of the two cross sections are 216 root 3 and 486 root 3. The planes are 8 feet apart. How far from the apex of the pyramid is a larger cross section in feet? Um, so let's draw it out something like this. Actually, wait. So yeah, I mean you can imagine that this is the pyramid. This is one of the pyramids, and then the second pyramid is of course a lot bigger, and that would look something like this. And this is just going right on through, right? So this distance over here, which I'm going to put in a different color, maybe like green. This distance is 8, and this distance over here is going to be some x, let's say, right? So the areas of the two cross sections, that means 8 plus x over x, right? The ratio of the area of this shape to this shape will be this height squared over this height squared. So squared is going to be equal to 486 over 216. Root 3 cancel out. There'll of course be a lot more cancellations here, I'm assuming. How do we find them? Well, so like, yeah, I think you can take out a 6 on both of these. 480 would give you 81 over 36, which makes it perfect for us because that's a perfect square, isn't it? 8 plus x over x. And even better than that, we can, yeah, I mean, so obviously we just square root now. This is equal to 9 over 6. Yeah, 9 over 6. So that's 3 over 2. How is this going to be true? Well, it's going to be when x is equal to 16, right? So when x is equal to 16. How far, yeah, I mean, and that works out as well. So that's not to worry about. What is the question asking? How far from the apex of the pyramid is a larger cross section? So that's going to be this 16 plus 8, which is 24. A right pyramid has a square base with perimeter 24 inches. Um, so square base like this, perfect. And then the perimeter, oh, okay. So this is going to be 6, 6, 6, 6. I was just checking that. Yeah, so the perimeter refers to the square, not the entire thing. This is going to be the height somewhere over here. And it's 9 from everything. So if you draw it out, it's going to look something like this. Wait, like, so, and the way this is going to be 3 root 3 because you're going from here to the center, right? It's like this. This over here is the triangle that we're talking about. The one that's in, I'll put it in a different colors just so it's very clear what I'm talking about. I'll do it in a light this color. Right, so this is going to be the height that we're looking for, and then this is the length that's given to be 9. This length right over here. And so if you can see, I mean, like this is going to be a right triangle. It just doesn't look like a very nice one, right? Hopefully that makes sense. Hopefully it's visible to you enough. Now let's actually like crack the question. So this is 3 root 3 and this is 9. What is this going to be? Well, it's going to be 81 minus 27, right? And that's going to be 50 what? 54. So that's 3 root 6. The units are fine. I think everything else is fine. So that's should be your answer. Okay, wait. From its peak to the center of its square base in inches. Did I do some math wrong? If it's a square with perimeter 24, it's 24 over 4, which is 6. Its apex is 9 inches from each of the other vertices. Oh, it's 3 root 2. Okay, that's very dumb mistake. Sorry. 3 root 2, which when you square, that gives you 18. So it's 81 minus 18, which is, I think, 63. Is it not? And that should be 3 root 7, which makes sense if you think about the fact that this would simplify to 3 root 2 root 7. Yeah, so perfect. 3 square roots of 7 would be the right answer. So I guess we had a little 6, 7 mistake there. Um, okay, what is it 10 units refer to? Slant edges of... Okay, I mean, this one doesn't seem difficult. A right square pyramid with base edges of length 8 root 2 each and slant edges of... Oh, okay. So the slant thing is 10. Yeah, okay, that makes sense. And then it's parallel to the base and 3 units above its base. What's the volume in cubic units of the new pyramid that is cut off by this plane? Okay, so because it's instead of 10, wait, 3 units above its base. So we have to figure out the height of the initial pyramid, and that shouldn't be too difficult because it's the exact same motif that we're using. 10 over here. This is going to be, maybe this will make it clear what I'm doing here. This is going to be not 8 root 2 but 4 root 2 because you're going to the middle, so it's like half and half. And so this is going to be in the end 8. If this is the case, this has to be 6, right? Oh, actually, it was drawn to scale. I just didn't realize it. If the height is 6, okay, so well, let's figure out the volume, right? What is the volume of this thing going to be? It's going to be the area of the base times the height over 3. So 6 times 8 root 2 squared over 3, which is 2 times 64 times 2, which is 128. Now what are we doing? We're taking, um, actually, let's not even write all that. Let's keep it like this for now. Let's keep it as a top expression. What we're doing is taking something that has half the height. Because it's got half the height, it's got 1/4, which is 1/2 squared, the base area. And so it's going to have 1/8 the volume. So it's 1/8 of 128, which is not 32 apparently. It's, oh, I mean, yeah, this is not 132, this is 256. So this will be 32. Okay. A regular tetrahedron is a pyramid with 4 faces, each of which is an equilateral triangle. So let's draw that out over here. Just like this. Wait. So this is going to be our base and then our height. It's something like this. Yeah. Let V be the volume of regular tetrahedron. Oh, I mean, okay. So let's think about it. If you extend this up like this, that's how you're going to get your tetrahedron, right? I mean, like, yeah, I should draw it just like this. This is a tetrahedron. Hopefully that perspective makes sense. How do we find, well, okay, I mean, how do we find the volume? It's always going to be the height times the base area over 3. What is the base area over here? Well, that's just going to be s squared, which is 1, so root 3 over 4 over 3. So it's h root 3 over 12. What though is h? Yeah, this seems correct. What is h? To find h, we can actually, oops, we can go back to this. This is 1, this is 1, this is 1, this is 1. What is, um, what triangle are we looking at over here? We're looking at this triangle, right? It's going to look something like this. And that's how we're going to build out our tetrahedron. To get this, we need to first find this. And what is this going to be? Um, if you remember from, wait one sec. Yeah, I mean, so this is this length over here. This entire length is going to be 2 root 3 over, it's going to be um root 3 over 2, right? So this part over here is going to be root 3 over 3 because it's 2/3 of that. So 2/3 times root 3. And that's because it's a centroid. I mean, I'm sure there are other ways to go about proving this as well. But yeah, I mean, like there have to be other ways to do it as well. But essentially, this length over here is going to be root 3 over 3. Because we found this to be root 3 over 3, this is going to be root 6 over 3, I believe. Um, yeah, I mean, that seems right to me. Root 6 over 3 because that's 2/3 when you square it. So this is going to be our h over here. And so now we can put them all together. Oh, we've taken up a lot of space here, I see. Yeah, I mean, we've done lots of questions. That's a good thing. But anyhow, continuing here, if you plug this in now, what do you get? You get, well, you get root 6 times root 3 over 3 times 12. That's 2. And so, sorry, root 2 over 12. Wait, no, 1 second. I think I messed something up. Yeah, I mean, so the 12 is going to, the root 6 times root 3 is 2 root, is 3 root 2. So the 3 goes and we're left with the root 2 over 12. They're asking for v squared though. So that's going to be 2 over 144, which is 1 over 72. That should be a final answer. That it seems off, but I mean, it might be fine. Yeah. And I think they did everything same way as we did. Yeah. There is a root 2 over root 3, which is probably better because it cancels out more directly than what we did. That's not to worry about. That's fine. Rectangle PQRS is divided into 8 squares as shown. The length of each, uh, what is the length of the side of the largest square? Huh. Um, it should just be 20, shouldn't it? Oh no, it's a rectangle. The whole thing is a rectangle. And what we know about the rectangle is that, so QR is going to be, I mean, I don't know, it seems a little bit weird of a question to me. I don't know. Let's draw it. I'm going to try to fill up as much space as I can so at the end it'll look nice. So there are three of these and they kind of go like this. I mean, okay, obviously not like that. Something like this maybe. Like these are all 10. And because they're 10, this length here is going to be 30. So we figured that part out. What else do we need to know though? We need to know, I mean, okay, this is, there are 4 squares over here. And these squares are going to have, it just seems weird. Like, I don't know what they're doing here. This is going to be like, let's say x maybe, right? If this is x, these are all going to be x over 4, right? Because these all have the same height. So these are all going to be congruent squares. Because it says that it's divided into 8 squares. Each of these is a square. We know that. If this is the case, what do we know now? Um, well, I mean, like, doesn't seem like a lot. All we know, I mean, yeah, actually it is. X over 4. So 5x over 4, the sum of these two is equal to 30. So x equals 24. That's it. I mean, that's all there was to it. I don't know what. Yeah, I mean, it just got little. It looked a little weird to me because I thought the whole thing is also a square, but it isn't. It's a rectangle. I just did a question like this from the geometry book earlier today. It wasn't asking this, it was asking for the height of D, like what is the distance between D and AB? And that's 1 over 8 plus 1 over 6. I know that formula now. But here they're asking for something else, asking for the difference in the areas of ADE and BDC. So, yeah, I mean, it's probably in, oh, well, I mean, yeah, this is kind of dumb. We get the length. Let me find a good place to draw this. Yeah, I'll just continue from like here maybe. Let's take a new color for this first of all. It's getting boring with the same stuff. Yeah, so what we have here is this situation. This is our first one, and then our second one is like not the same height, so I'll do it like this. Maybe. This should be good. This is 4. What is this going to be over here? Because if we want to, so we can figure out the area of EAD, ADE, and BDC by finding the area of ABC and ABE and then subtracting off ABD, right? How do we want to go about doing that, right? There has to be a good way to do it. What is the area of this? What is the purple area? That's just going to be 16. Now we can do the same thing for the other section and we can call this like the pink area, something to that effect. And that would look like this. What would that be? This is 6, right? So this is going to be 12. And what we want to find now is this area in the middle. And let's do this in like blue. So it really pops. What is this blue area? How can we find that? Well, we need to find the height for that, don't we? How do we find the height? It's going to be 1 over 8 plus 1 over 6 and then 1 over that. I think that's a formula. Wait. I mean, we'll see logically if that makes sense or not. But it should in theory. And let me like test it out, if you will. Yeah, I mean, I don't think there's a 2 here or like 1/2 or anything funny like that. It should be fine. And then this would make it 6 plus 8 and then over 48. So that's 48 over 14. You can take out 2 from that, 24 over 7. I mean, yeah, perfect. 24 over 7 is our height now. Oh, wait, why does it even matter to us? It's what is the difference in the areas? It has the difference in the areas is going to be 4, regardless of anything. Because it's, like ADE plus 4 is 16. Sorry, ADE plus X is 16, and then D is BDC plus X is 12. What is ADE minus BDC? It's going to be um, 12 minus X minus, sorry, 16 minus X minus in brackets 12 minus X. So that I should have read the question, but I don't know why I did that. But that's fine. Let's move on to the next one now. Here it is in PQR point T. Okay, let's just draw it out like this. So this should be 6, this should be 10. What is the ratio of the area of PQT to the area of PTR? It's just going to be like this is same base to same height, so it should be 6 over 10, which is 3 over 5, right? And like same base, same height. Yeah, okay. Or same base, same altitude, whatever it's called. I don't remember. In rectangle ABCD, wait, also let me like write down somewhere convenient where we started this. I think we started at question 918. There's probably a way to check later on. Okay, so I mean I think that's where we started. We'll find out. Oh, this is a hard one. I think this is from the geometry book or just generally. I know I've tried this exact question before, and I know that I didn't get it last time. So I saw the solution. So let's see if that solution stuck with me. Find the area of triangle EHJ. So that's like the small triangle over there. Yeah, I mean I know I struggled with this one a lot. So hopefully I won't do it. hopefully I'll learn something from it. So this is going to be a big rectangle, ABCD. Then we've got diagonal AC like that. The area of rectangle ABCD is 70. Find the area of that. Okay. So we can give them lengths later on. What else do we know? We know that AF equals FG equals GB. So this is broken into thirds, kind of like this. All of these are thirds. These are equal. Okay, I think that looks good. What else is there? Also, I mean, yeah, I think that's it. Now we want to make some triangles from this, don't we? How can we do that? Well, let's see. Let's try to do this smartly. Okay, what happens when we... I mean, okay, I think we can use analytic geo... No. I mean, it's probably possible to use to make equations of lines and then see where we go. But the thing is, I don't think so because we don't know the height of CB or AB. We just know their area. So I think we have to use ratios, like similar triangles, and then use those ratios and see what we can do with that. And I don't immediately see any similar triangles here. So that's the other problem. But I'm sure there will be some. So like, um, these angles are all the same, right? They're vertical angles, but how does that help us? What can we do with that? I mean, okay, I guess we can draw this over here, and now we get a pair of a pair of similar triangles. And so, okay, let me clear the miscellaneous stuff, the stuff that we don't need. Okay, so I want to shade in, not shade, I want to just like kind of annotate the ones that we have. So this is one of them. What's its length over here? Like the length, we know the length. It's going to be 1/2 of the total. And then this over here, what's its length? Can we figure that out? Also, wait, let's just verify. Yeah, I mean, they do have to be equal, assuming that this is parallel, which is the way I drew it. That's why I drew the line to be parallel to that, to DC. Let's see though. So what can we figure out from this? Where is... hmm, like it doesn't seem to have to be the midpoint. If we can figure out this length, we should be fine. But if we want to figure out that length, there's a lot of other stuff we have to figure out as well. So let's see. This is going to be... let's call AB X. And I think I'm kind of blocking you with my camera now. So I'm not sure. But let's call AB X. And this is going to be X over 6. Let's call this big thing Y. Right? And then um, when that's the case... Okay, wait, there might be some other stuff that we can do as well. So yeah, and then let's CB or AD maybe equal Y. Then this entire thing is Y. So this, I mean, we can figure out the length. We can figure out the length FE or EF in terms of X and Y, but that doesn't really make it nice. It makes it very messy actually. And I don't want to do that. Um, what, I mean, there should be something else we can do with this, shouldn't there? Yeah, oh, okay, wait, maybe this is what we can do. If we can... so it's all symmetric, right? So what I think there's an alternative that we can kind of use here. I'll do it in green. We know that this triangle over here is 1/4 as large as this because it's half in everything. That also tells us that this height here is y over 2, for instance. This is x over 2. And so, I mean, that's something to work with. If we can now use that information to our advantage, can't we figure out some more useful stuff? Like we now know that once we figure out this side, once we figure out the area of this thing over here, we can figure out y by subtracting that off from um, 70 over 8. So the total, okay, so let's at least get some numbers in somewhere, right? This area here is 1/4 of 1/2. So that's 1/8 of the total thing. So that's 7. So the total green area is 70 over 8, which is all of this. Okay. And so what we now want to do is figure out, sorry, what we now want to do is figure out, oh, wait a second. No, no, no. There's an even better similar triangle than that waiting for us right here, isn't there? And that similar triangle is this one over here. Right, I completely forgot about that. This is also a similar triangle, except I mean no, I mean it is a similar triangle, and we also know we know its ratio. It is so it's gonna be 4/3 as long. This entire thing is 4/3 as long. And that helps us because it now makes it so that we can wait, I mean I hmm, it's 4/3 as long, which means that I sense that we're not too far from the right answer now. Getting closer. Um So the area is going to be 16/9 as much, but how does that help us necessarily? Maybe you can give it assign a variable that will give us the area of this over here, right? And so we can kind of call that anything we want, really. Let's go with just a. Then this is 16a over 9, which gives us a total of 25a over 9. We can also figure out from that. Okay, wait. This is 4/3 as much as this, right? That's a ratio that we settled on. So what I think we can do then is, yeah, I think this, wait, the ratio doesn't seem to work out. What have I done? It's 2/3 to 1/2. No, I mean, that's fine. Sorry, I just didn't believe myself there for a second. This will be 4/7 of B. This will be 3/7 of B. Whatever B is. I know I'm choosing like dumb variables now. But the point is, if we know that, can't we also tell that, hmm, And there has to be something else. It's a similar triangle in here. What is it though? Oh, perfect. Mm, no, wait, not necessarily the case. I was thinking that, um, no, never mind. Never mind. Um, I was thinking that we can figure out what this length is, but I don't think that's the case. I think there's probably something more complicated we have to do than that. At the same time, I don't think the question is meant to be this hard because I've done it before and I remember it wasn't super difficult. Like the solution seemed fine, it was like manageable and everything. So it's more to do with the fact that I'm not seeing the breakthrough, which is kind of, you know, annoying me a little now. I'm not sure what, like, okay, maybe we can. So this triangle that we've drawn here doesn't help us much particularly. What can help us though? We know that, okay, maybe this could help us out a little. We've got this ratio. We know this is G. So I mean I'm sure it's going to end up not doing anything, but there's no, just in case it does, right? Like I'm not too sure how the math will look. What we should get here is this total thing, this total yellow thing will be what? I think 3/8 of the no, 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 not 3/8. It'll be, well, yeah, I mean, won't it be three? It'll be some nice ratio. And okay, I think it's not that bad now. So let's draw it out, right? We're gonna have this entire section. This entire section is going to be 35, right? Yeah. And so now when you subtract off this, what are you removing? This is 1/6. This is 1. So it's 1/12 of 70, right? Right. So it's 70 times 11 over 12. No, sorry. So it's 1/2 of 70. 35 minus 1/12 of 70. So that's 70 times 1/2 minus 1/12, which I think is 70 times 5 over 12. Finally, okay, thank God. No, wait, that this still doesn't help us, does it? I mean, we can figure out A all we want, but where does that take us after this? I don't think that, I think I kind of messed up with that actually. No, wait, no, 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 no. We know what it is, right? It's 70. Okay, we'll figure. It's going to be a messy answer, but I think we'll get it now. So 70 times, so 350 over 12 is this entire thing. So this is 350 over 12 minus A. Now finally we can finally add these two together. And what is that going to be? It's going to be 35. So 16A over 9 minus A plus 350 over 12 is equal to a total of 35. Very messy answer, but I'm sure there's a simplification here. I think I see it. 7A over 9 plus 350 over 12 is 35. Did I do that? Did I do that right? Yes, I did. We can divide it all by 7 now. So A over 9 plus 70 over 12 is equal to 5. Okay, wait, no, no, something's off. I'm getting A to be negative over here somehow. So obviously that's not correct. Let's double check once. If I did my math correctly here. If that's A, okay, I mean 2/3 divided by 1/2 is 4/3. That part is correct. So the area is going to be 16 ninths as much. Did we do the part 350 over 12? Is that correct? Yeah, I mean it should be 70 times 5 over 12. Does not seem wrong to me. 16a over 9 minus a, that's 7a over 9. So, okay, 7a over 9 plus the 350 over 12 is still equal to 35. No, wait, I'm just being dumb here. It's fine. There's nothing wrong with that. 50 over 12 is equal to 5. Yeah, I divided by 5 instead. Okay, sorry about that. This is 9, just so you know. So a over 9 is now equal to 10 over 12, which is 5. Okay, it's horrible. 9 and a over 9 is equal to 5 over 6. So a should then be 7.5, right? Yeah, it should be 1.5 times 5, so 7.5. Finally, we found a. That still doesn't take us, that doesn't take us all the way there, but it's almost there now, right? Because what did we say this entire green thing was? It's 70 over 8 minus 7.5. What is 7.5 as something over 8? It's 60 over 8. So that's 10 over 8, which is 5 over 4, 1.25, which does not seem correct at all. Like, look at the size of that. But at the same time, you know, what is 7.5 times 8? 56? Yeah, I mean, I think it's just maybe not drawn to scale then. That's probably the case. Come on. Okay, what did I do wrong here? Did I do that right? I mean, I put in, this is definitely the closest I've come to solving this question, and I don't know why, because like I was doing the other ones, I haven't gotten a single question wrong outright, except for the one where I forgot to, where I forgot to multiply by 4 for the volume or something like that. I did 4 root 3 instead of 96 root 3. But here I don't see, like I've checked my work, I've made a few mistakes, but I fixed them. So I don't see the issue with this. Hmm. What is 35 times 12? That'll be 350, 70. Maybe I did some math wrong here. Yeah, that's probably it. So, no, it seems right. Oh, wait, no, I think there's probably some mistake here. Let's see. 5 over 6. So, 45 over 6, no, 7.5 is correct. Did I do this equation right? I think I did, right? 16 over a, 16a over 9 plus 350 over 12 minus a is equal to 35. The 35 is correct because it's half of ABCD. Yeah. Just like that part is correct because it's 70 times 1 half minus 1/12. Does a 1/12 make sense? Yes, it does. Does a 1 half make sense? Yes. 12 minus 2 over, and that's 6/12 minus 1/12, which is 5/12. And then that multiplies to 350 over 12. Yeah, 16a over 9 minus 9a over 9 is 7a over 9. Plus this is equal to 35. I divided everything by 7. I did that correctly this time. 5 minus 50 over 12 is 60 over 12 minus 50 over 12, which is 10 over 12, which is 5 over 6, or 90 over 12, which is 7.5 again. Goodness, if that is 7.5, then it's just 7.5 again. Okay. Um. Oh, wait, no, that's not the answer that we're looking for anyway. That's just this portion of it, which doesn't help us at all. Okay, fine. Yeah, okay, sure. Okay, no, so never mind. That all that might be right. 5 over 4 will give us this area. The calculations all seem right to me. I just forgot what they represent. So this area is 5 over 4. And it's not looking good for what we've done so far. This is kind of a waste of time. Um, I really don't see how that's helping us at all. Like, so how do we relate the um the bigger section now? Like, I mean, I'm not going to do all this work again to find some other part of it. I need to finish off the question now. We found out one piece. How can we find the next piece from here? Is there anything that's similar to this? Like, it's a really stupid thing that I did here. So 5/4, 5/4. Um, okay, on the bright side, we do have all of these lengths now. If we can figure out, I don't know, I think I've messed this up or I've done something. I've just wasted a lot of time. I haven't solved anything. Oh, also, I don't think we need to do all that work at all. I think we could have just figured out the fact that, well, you know, this actually helps us with one thing. We know that this triangle would have, okay, so this is 5/4, right? What would this have to be? This would have to be um uh 1/12th, right? I think we decided that this would be 1/12th, so it would be 70/12. And so, wait, let's go up here. 70/12 is the entire area. We're subtracting off 5/4 from that. So that's 70/12 minus 15/12, which is 55/12. 55/12 is this part right here. What is 16a/9? What is a? What was a? It was 15/2. So 16a/9 is going to be 8 times 15/9, which is 120/9, but we can cancel out a 3, 40/3. And so let's see this, yeah, so the entire thing would be 40 divided by 3 to minus 55/12. That's going to be 120/12 minus 55/12, which is what, 65/12. Perfect. If this is the case, no, this does not help us much either now, does it? I mean, I can figure out everything but what I need to find over here, it seems. Yeah, I mean, does this really help us? Oh, wait, I mean, I guess it gives us the height in a way. It tells us that Wait. Based on the ratios that we know, what if we draw this line over here? We know that this is going to be 3/7 of y. So this is y times 3/7. This is 4y over 7. So this area is going to be 40. This area is going to be 30. And we can figure out different sections of that by virtue of the fact that, um, I mean, okay, there are two different approaches. I think both of them are going to get us to the final answer eventually. It's just not going to be pretty. Um, Also, we can't make more mistakes because I already messed up once when I answered the wrong thing. Another thing that we could do would be to draw DB and make it completely symmetric and then see what we can do from there. But I don't think that, I don't know if that would necessarily help us. I think I've made it very messy now, so let's say kind of backtrack and do it elsewhere. I've also seen this figure so many times that I can probably draw it pretty well by, I'll like write down all our observations here again. So something just like this. Yeah, and then we figure out this part. Actually, I shouldn't draw that. That's making things worse for us, isn't it? Let's try this instead. And we know that this is going to be 3/7 of the height, and this is going to be 4/7 of the height, which is from that ratio that we discovered earlier. Um, yeah, I mean, if this is the case, oh, wait. Yeah, I mean, wait, this should not be so difficult now. Where do we, can we like repeat this? Is there anything similar to this triangle anywhere? There most certainly is. Isn't it just this entire section over here? This entire thing is similar to that. It is. And what is the height of that entire thing? Oh no, wait, even more obviously, isn't this over here, this triangle similar to this triangle? They both are similar. And we know that, I mean, I'm sure we can figure out the ratio. What would the ratio be? What would the ratio here be? It would be, um, yeah, I mean, and the reason I'm doing this is because we can now kind of figure out this area just by making use of the fact that it's, uh, so this would be 1/6 as much, and then it would be 3/7 squared of that, wouldn't it? Something like that. Yeah. Yeah. 3/7 of that squared times 1/6 of 70. Of 70. That's this section over here. What about this bottom one? I think we can figure out the bottom one by using some sort of similar triangle again. But what type of similar triangle can we use? There are probably a few different ways we can do this. I think, I mean, like, is there some sort of symmetry here? Um, First of all, yeah, these do have to be the same type of shape. This distance here, do we know this distance? No, we don't. Um, yeah, okay, this is a little worse than I thought. I mean, if this would magically become 3/7, that would probably make our work a bit easier, but it doesn't work that way. On the other hand, what would the area of this entire thing be? Didn't we figure out the area of JHFG? We did, didn't we? Yeah, we did. We did. JHFG. Oh no, wait, we didn't do that either. Never mind. Actually, I should probably get rid of this line because it's only going to confuse me more on what we did and didn't do. Yeah, no, we didn't find that on its own. We found like other stuff, but not that as you would have wanted to find it. Okay, like let's while we're not doing anything useful, let's evaluate this at least. It's gonna be 9 divided by 49 times 70 over 6. No, sorry, 10 over 7. What am I doing? Yeah, at this stage we know that it's going to be an integer, right? Because they don't have that other clue thing. What sort of integers can it be? It's a little bit over 2, so it's probably either going to be 3 or 4. I don't think it's going to be 4 because that would imply that it's almost as big. So I'm going to guess 3 for now. I'm not going to write it though because that's pretty dumb to just like give up on all the work and just guess. But if I had to guess an integer right now, I would probably put 3. Um, yeah, but obviously that's not legitimate, right? That's not how you do it. So let's see. Let's say kind of keep tackling this if we can. Can we make use of the fact that do we know the area of this? Yeah, I mean we do. We also know the area of this entire thing. Can we use that to our advantage and maybe figure out something else? So yeah, I think we can um, do something here. What is 16a over 9? We found that out, right? That's 40 over 3. So this entire thing is 40 divided by 3. That's the area. Um, Wait, that's so dumb. We didn't have to do all the math for that. I mean, yeah, okay. There's a faster way to find that as well. I just discovered. But actually, wait. No, so if that's 40 over 3, can we figure out what this must be? Um, well, we should be able to. Yeah, okay, I see. This triangle over here is going to have not 4/7, but 16 over 49 times 35, I believe. And so, with that being the case, we can now hopefully finally put this to bed. Yeah, I mean, it's just going to be a lot of similar figures, but I think I can finally get it now. What is the area of this entire thing? It's going to be 5/12 of 70, which is we discussed. I mean, at this point, yeah, 350 over 12 is fine. That's this entire thing. This is going to be Okay, wait. Right, it'll be 4 over 7 times 4 over 7, 4 over 7 squared, because of the fact that it's just like, yeah, I mean, I think, what am I doing here? What is this going to be? That's going to be 35. And so it's, I think we need like one more variable name. Let's call this x over here. Then this will be some a squared x for some ratio here. And now, okay, and now I think I get it. This is going to be, what is this going to be? Well, no, this is just going to be 1/6 of 70. 70 over 6, which is 35 over 3 minus minus x. But we know that the bottom thing is 45 over 3, right? And so, sorry, we know the bottom thing is 40 over 3. So this over here should then be 5 over 3 plus x. 5 over 3 plus x. And what do we know about this over here? This entire area is equal to what we have over here. So that'll give us 40 times 20 over 12 times 7. Right, 20. No, wait, sorry. 70 and 4 over 7 give you 40 over 7. No, sorry, they just give you 40 times 20 over this. Um, so 16 over 49 times 35. That's, I mean, I should have cited this. 4 over 7 times 4 over 7 times 7 times 5. 16, 80, 80 over 7. So this over here will be 80 over 7 minus x. But this does not help us. How does this help us at all? Wait, no, I don't think that's even right, actually. It's something is definitely wrong over here. Because what is 80 over 7 plus uh, 5/3? That would be this answer over here, but that does not seem right to me. Because this is 240, 275 over 21, which can't be right, can it? Yeah, that's not right. Wait, no, where did I get 80 over 7 minus x? Where is the... Okay, that came from right here. We know that 80 over 7... Hmm. If we take out a 4, we get 200... No, wait. 200 over 21? Mm-hmm. Mm. Um, and so based on this, I'm getting this entire thing is 200 over 21. Well, where did I get the 35 over 3 from? I don't think that math is correct. Where did I get that from? Um, yeah, where did I get 35 over 3 minus x? So that means that these two are 35 over 3. Is that necessarily the case? It'll be 1/6 minus, oh, this is 15 over 7, is it? I don't know that. That seems off. But, oops. Okay, no. If this is 15 over 7, this will just be 15 over 7 times 7/3 times 7/3. 7/3 minus minus 1 minus 15 over 7, which is 35 over 3 minus 15 over 7, which is 210, 245 minus minus 45. What? Which is 200 over 21. And so that's not the same as this at all. So I don't know what I did there. But at the same time, now this is just like some stupid circular loop, isn't it? Because this is 200 over what? 200 over 21 minus x. Well, no, okay, now we know that this is 40 over 3. And what is, I want to clear up some space over here, like right here. What is 40 over 3? This is 280 over 21. And so this right here is going to be 80 over 21 plus x, which doesn't help us at all. How does that help us in any way? Yeah, I mean, I don't know. I'm getting a little annoyed with this now. It really doesn't help us because it's all adding up to what it should add up to, which is 80 over 7 over there, 280 over 21. Maybe this approach is also wrong, but like now I'm getting a bit very annoyed because when will this end? Like, there has to be some sort of solution inside somewhere, right? If this area, okay, how much was the top area? How much was A? A was 15 over 2. Like we figured out almost every single piece of this thing. Um, yeah, like we've got most of it now. So yeah, and what would like 9 over 49 times 35 give you? 9 over 40, that's 9 over 7 times 1 over 7 times 5 times 7. So cancel 45 over 7, right? Yeah, 45 over 7. And so like that doesn't really help us. What would this section be? We figured that out, didn't we? We figured that out somewhere. Yeah, maybe let's brainstorm with it. Oh, no, I think I got it. I think I had some solution over here because this is 1/2 as much. Um, is this 65 over 12? Wait, that can't even be right. Like that has to be wrong because that should be exactly 1/8 of the total area. So something's wrong over here. I've also wasted like probably half an hour on this. It would be a miracle if anyone's still watching this because I've just been hanging on to the same question for so long. Let's see. I'm gonna guess three because that's like the only feasible area I can think of. Yeah, I mean that was a prediction because this is 15 over. Okay, and oh wow, that's it. We just had to draw one line. The area of EFG is EFG. Yeah, we got that 35 over 3. Triangles AFH and CEH are similar. We definitely thought of that one as well, didn't we? Oh no, I did like the other similar triangles, maybe not that one. So 3 halves times EC, 3 halves is equal to EC over AF. Yeah, because it's one of them is 1/3 and one of them is 1/2. Fine, and then you get those ratios. So EH over EF is 3/5. Yeah, that makes sense as well. Triangles AGJ and CE. Wait, AGJ, yeah, we made use of that. Are similar, so you get 3/7. Since the areas of the triangles that have a common altitude are proportional to their bases, the ratio of area EHJ to the area of EHG is 3 over 7. Okay, it's same base, same altitude twice. That's what they did here. The ratio of, okay, the ratio of EHJ to the area of EHJ, EHG is 3/7, and then EHG to what? To EFG is 3/5. Oh, 3/5 over 3/7, it is 9 over 35. So it's 9 over 35 times 35 over 3. Fine, 3. That I'm not going to count that as correct. Like, I mean, yeah, Alchemist will, and I'm not going to stop it, but all of this work was completely useless because we didn't really do anything with it. Yeah, I mean, I should have thought a little harder about what I was doing there. Okay, glad we're done with that one now, though. I think we've basically screwed up the time challenge completely, so we'll see. In a rectangle ABCD, points E and F lie on segments A and B, such that AE equals AB over 3. So A, B, E, C, D, F. Segment BD intersects segment EF at P. Yeah, let's just go with this and then like that. What fraction of the area of ABCD lies in E? This is P. Wait, what is segment BD? Yeah, EBP. So that's this over here. So now we want the proportions on this, don't we? Well, we can see that mm, these two triangles are similar, right? And so the common ratio is again going to be 3 halves or 4/3, I think. Yeah, 4/3. So this will be 4/7 and this will be 3/7. And so if that's the case, this is also going to be 4/7, and this is going to be 3/7 by similar triangles. So 4/7 times 2/3, which is 8 over 21. And then you divide that by 2, so that's 4 over 21. Yeah, okay, fine. I think maybe I just was being stupid on the last one. Let's see. The Pythagorean theorem over here. ABCD is a rhombus with side length 6. So let's draw that out. Oh, okay, wait. So the way they're doing this is that they're wait. Measure of angle ABC is 150 degrees. ABC is 150 degrees. So they're drawing it like this. This is E, and segment BE is perpendicular to base AD, and F is a midpoint of segment BE. So this is F. The length of segment C. Okay, wait. What is this? ABC is 150. So this should also be 150. If that's 150, A has to be 30, doesn't it? If that's the case, this has to be 60. This has to be 90. The length of segment CF, wait, side length 6. So this is 6. If that is the case, okay, wait, it's drawn badly. This is going to end up giving you, wait, I'm getting some somewhat weird answers. If you, so 60, yeah, I mean, so this BE should be 3. It really doesn't look like that, but I mean, that's what they're saying. So, yeah. If B is 3, then this is just going to be 3 over 2. And what else is that? BC is 6. What are they asking for? CF. Yeah, I mean, that's 6. Okay, whatever. That's kind of weird. What do we get now? We get 3 times 1 half, and then that's 2. So 1 half squared plus 2 squared, square root of that. The 3 is out, so we're fine. This is 1/4 plus 4, which is 17 over 16, right? No, sorry. 17 over 4 to the 1 half, so that's 3 root 17 over 2. Adding it all up, it's 22. That's it. Okay, that was much easier. For example, special right triangles. In pentagon ABCDE, BCCDDE. So BCCDDE. This is a right triangle like that. And measure of angle B. So where we start, this is BCDE. These are all 135. I mean, okay, 135. What do they add up to in a pentagon? What do they add up to in a pentagon? They add up to 540. So clearly something's not right here. It. Yeah, I mean, okay. So we can figure out the angle A then, can't we? If it's 90, these add up to 270, 360, right? And so if that's 360, this should be 45. So this should actually go on to like here. Ah, yeah, okay. I think that fixes it. Okay, so I mean, yeah, it looks very ugly, but this seems fine. A should be here, obviously, not there. How do we proceed from here? The length of segment, okay, so these are all 2, right? BC is 2, CD is 2, this is 2. How do we continue from here? They're asking us for AE, by the way. Okay, so, I mean, one thing we can do is probably draw this perpendicular. And upon doing that, wait, looks, I've drawn it really badly, so I need to think this through. When we break this up into 90, so I mean, the way I've drawn this is definitely incorrect, but ideally we should have this situation where this is right and this is right and this is 45. Okay, now that this is right and this is one, okay, let me just redraw it because this is not working. So I think it should be like this in the end, right? This is 45-degree angle, that's 135. E is like this, and we have another 135 and 135. So again, I mean, this should be drawn better. Maybe I can just draw it a little bigger so that it's easier to work with. Oops, so that's obviously not what we want. Wait, this isn't even enough vertices, is it? A, B, C, D, E. Angle E is a right triangle. Okay, wait, 135, 135, 135. Okay, that's sufficient. We don't need to be doing more than that. So this should be fine now. 135, 135, 135. A, B, 2, C, 2, D, 2, 90. This is E. Okay, now we can draw this, can't we? And upon doing this, what do we get? This is 90. Um, this makes it a square. 45, 45. Looks very messy, but it's right. What am I can't really do much about that. This is root 2. This section is going to be 2 again. This is 2 plus root 2, right? And so what is this going to be? This is going to be the same as that, 2 plus root 2. So we get 2 times 2 plus root 2, which is 4 plus 2 root 2. B is 2, A is 4, the answer is 6. Okay, I mean that just looked terrible, but it works, so that's fine. 30, 60, 90 triangle is drawn on the exterior of an equilateral triangle so that the hypotenuse of the right triangle, if the shorter leg of the right triangle is 6 units, what is the distance between the two vertices that the triangles do not have in common? So that's just the Pythagorean theorem, right? It's 6 root 3 and 12. So 12, 6 root 3. What does that give you? 140, no, sorry, 36. No, 144 plus, that's actually 6 root 7. Hmm. Very nice answer there. Well, I'm glad I did that in my head. At least finally it's not as bad as it was before. Let's see. What do we do? What would we do here? BAC is 72. So that would tell us that EDF. Okay, so EDF will be 180 minus 72 divided by 2. So that's 108 divided by 2, which is 54. In triangle ABC, AB equals AC and D is a point, so that BD bisects. Okay, let's draw this out. In triangle AB, so AB equals AC and D is a point on AC such that BD bisects angle ABC. What is angle ABC? That's this one. So that's right here. If BD equals BC, how is that possible? What is the measure in degrees of angle A? That's x. That's x. This is uh, 180 minus 2x, so 360 minus 4x is equal to x. So x is equal to 72, 144, so 36. Okay, yeah. What I did here, so this, I found x to be 72. So this will be 72 more. That's 144. So this has to be 180 minus that, which is 36. Mm. 10, 17, and the square root of 21. I mean, I don't think that looks like a. This is going to be obtuse, isn't it? Yeah, I mean, it's definitely an obtuse triangle. What do they want me to do with this? AB is 10, AC is 17, and then this is 21. It's definitely a big triangle. What are the thing look like? I mean, it still should touch all of these, right? What's the property of this? I kind of forgot. It's the it should be the same distance from all of the points. Is that what it is? Well, yeah, I mean, obviously it has. Okay, that's what a radius is. So let's see. All of these are easy. I mean, all of these are equal. How do you like actually do anything with this? So what is the radius of the circle inscribed in the triangle? Oops. So 10, 17, and 21. We're gonna have a circle inside of this. There, just like that. This is going to be one of our things. This is going to be another one of our things. This is going to be another one of our things. So the area, there's a relationship here where you use Heron's formula. And I think so yeah, I mean, I don't think it's that difficult to show. This is one triangle, two triangles. That's it. Yeah, okay, so this is going to be, hmm. Is there a way I can like find the area quickly? I mean, okay, no, I think the way we can do this is by saying, so this is going to be x, this is also going to be x because it's a tangent. This is y, this is y, this is z, this is z. X plus y is equal to what? 17. Y plus z is equal to what? What is it? The radius times the semi-perimeter. For the reason that, so this length times the radius is going to give you this area over here times 2. You only want half of that. Same thing for y plus z, right? And then same thing for z plus x. So the radius times that is going to be the area of the triangle. I mean, yeah, you can just write that like this. What is the area of the triangle? To find that, like, there should be a good way to do this. There should be a good way and a bad way to do this. And I think I'm on the bad track. Uh, okay, no, wait, why am I doing this? If you add all of these up, you get 38, 48, so 24. So z is going to be equal to 7. X is going to be equal to 3. And then what's the other one going to be equal to? The other one is going to be equal to 14. Y is the longest one at 14. Yeah, okay, okay. And so, oh yes, wait, no, 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 no. We now want to find the area of the rectangle. Do we have to use Heron's formula here? That's going to give us, well, it's probably not that bad. 24 times 24 minus 10, 24 minus 17, that's 7. Okay, I think it's going to cancel out. And 3, yeah, okay, it's not bad. 8, well, okay, let's do it like this. 4 times 3 times 3 times 2 times 14 times 7. This is 14 squared. This is 2 squared. This is 3 squared. So just 2 times 3 times 14, which is 84. 84 is the area. The semi-perimeter is 24. So it's 84 over 24. What is that? I'm going to use a calculator for this. No, actually, you're not allowed to do that on the AME, so, or the AMC, neither of them. So it's just 21 over, what did I take out? I took out a 3, took out a 4. So it's 21 over 6. Oh, I can just take out a 12. That's 7 over 2, which is 3.5. Yeah. Didn't need a calculator for that. What is the radius of the circle inscribed in this triangle? If it's 15, 41, and 52. Um, so again, it's not going to be pretty. I think we just use the same formula. RS equals the area. So what is 15 plus 41 plus 52? That's going to give us 53, isn't it? Let's see. No, I think 54 actually, because it's 11 plus, yeah, 54 times 54 minus 15 is 39. That's 13. Okay, yeah, I mean, I see. 2. And now we're just going to get some nice simplifications, I guess, right? This is 3 squared times 2 times 3 times 3 times 13 squared times 2. So that's 9 squared. When you put all the 3's together, times 2 squared times 13 squared. So they're just being nice to us and giving us comfortable answers. 240, no, 234, I think, because it's 9 times 26, so that's 260 minus 24, so 234 divided by 54. We're going to get a 9 from this. What are we going to get on the bottom is 6. We're going to get an 18 from this actually. So 3, 18, 10, 13, 3. Okay. Point P is inside equilateral triangle ABC. Such that the altitudes from P to ABB 5, 6, and 7. What is the area of the triangle? So 5, 6, 7. Let's see. I guess you can like so draw this line here. Okay, now we know that all the side lengths are equal, don't we? And if that's the case, That's my first guess, but that's just a guess. Let's see if we can like actually show this in some way. So what I'm doing is assuming that the 1 through 6 will like touch it. Um, that the line through 6 going to be is going to bisect AB. Yeah, I didn't even draw it right because this one should be 6. This should be 6. Okay, well, like let's see. There should be some way to do this fast. If they're 5, 6, and 7, it's an equilateral triangle. So the actual distance that you are from each of them, I think, would be 6. Or like let's draw this out again. Actually, here. Let's say that this is the point. Oh no, it is altitudes, so it would be like 5, 6, 7, right there. And now which one is 6? So okay, this is point B. 5 is with AB, so this is going to be C. 6 is with BC, so this is going to be A, B. Then AB is with 5. Okay, this makes sense. Let's see. I mean, actually, none of that really matter. The names don't matter at all because it's all the same. What can we do now? I mean, this is going to be the same length. We can call this X and we can call this Y. We can call the entire thing L. So we know that L minus Y, L minus X, L minus Y over here. Okay, is this enough to solve it or no? We're gonna have three variables and three equations in the end. That's what I think. Yeah, I mean like let's call this Z and then this is L minus Z. No, we're gonna have four variables and three of these. So that's not going to work out. At the same time, like, I really don't see an alternative to this. How else are we going to solve the question? Um, I mean, actually, maybe it is doable. No, that doesn't make sense. Okay, what do we think about it like this? You know that the total area of the rectangle of the equilateral triangle is going to be 5 times the side length L because this entire thing is L. So it's 5L plus 6L plus 7L from each of those divided by 2. But if we take another point, then we'll get 6L plus 6L plus 6L, which adds up to the exact same thing. So we can take another point and just ignore this entirely, Q. Now this is 6. If this is 6, this is going to be 12. If this is 12, this is going to be 6 root 3. This is going to be twice as much, so that's 12 root 3. And 12 root 3 squared root 3 over 4 is going to be 144 times 3 times root 3 over 4. 36, which is 108 root 3. Yep, 108 root 3. Oh, I mean, I guess you could also equated it with the fact that it's, you understand, let's check this actually. So what does this give us? This gives us 9L. That would be the area, and that's the same thing as L squared root 3 over 4. So you get 36. Yeah, I mean that would have been the exact same thing that we could have done, and we could have also then just put this in here. That would have been a faster way. So yeah, I mean I was correct in the very beginning with my hunch, but the hunch isn't a good thing. I mean I should have known how to do it properly, and we did that, and it was actually easier to just do it the right way. So let's proceed with this one. A regular tetrahedron. Okay, this one just looks hard. A regular tetrahedron is a pyramid with four faces. So these are our four faces. A, B, C, D, and P with a unique point equidistant from all of them. Extend AP to hit face BCD. Extend AP to hit face BCD at a point Q. What is the ratio PQ? What is BPQ over AQ? Okay, this doesn't look that hard actually. So the point is going to be right here. Um, this is going to be Q. And what we now have to figure out is PQ to AQ. P is going to be like right there. Okay, what is the distance? Let's call this A, B, C, and then D up here. DP, can we give this the side length 1? Yeah, let's just do it with X. This is X. What is AQ going to be? AQ, first of all, AQ is obviously one of the things that we're looking for, but that's also going to help us here because AQ is going to be, and we did this earlier as well. It's going to be from the centroid thing. So X root 3 over 3, meaning that um DP, so DQ would be, let's write this now. AQ is X root 3 over 3. DQ would then be X root 6 over 3. Now we need to find a value P such that PQ, so okay, PQ squared plus AQ squared equals well DP squared. And dp squared is going to be equal to, I mean, okay, so pq is just going to be dp, no wait, it's going to be, so what is dq is x root 6 over 3 minus dp squared plus aq is x root 3 over 3 squared is equal to dp squared. Wait, this is kind of a stupid way of doing it because instead of doing this, we can also do, they're asking us for PQ, right? We know what AQ is. They're asking us for PQ. So why not just solve for PQ, right? PQ would be, um, uh, PQ, yeah, so PQ squared plus x root 3 over 3 squared is equal to dp. What is dp? dp is going to be, isn't that just going to be dq minus pq? It is. Square that. Let's call pq y, so that's a little easier. What is this going to give us? That's going to give us 2/3 x squared minus 2. Okay, careful now. 2xy. Huh, this is getting kind of messy. 2xy root 6 over 3. No, never mind. It's not messy at all. Plus y squared. Luckily, the y squared and y squared cancel out. And we get 2xy over 3 root 6 is equal to x squared over 3. Cancel out an x and an x over here. Cancel out a 1/3 and a 1/3 over here. Wonderful. We now have y is equal to x over root 6 times 2. What is p? That's pq though, isn't it? And they're asking us for pq over aq. So it's x, it's this divided by x root 3 over 3, which is x over root 6 times 2 times 3 over x root 3. And this cancels with this. So you have 1 over 2 root 2, which is root 2 over 4. Let's verify that they want all of that stuff. Oh, there should be no square root in this apparently. So something's the matter with our calculations here, it seems. Let's just double check once. I did do PQ over AQ, right? PQ is Y. And so x over 2 root 6 times 3 over x root 3. So that's times root 3. Mm. Yeah, wait, let's check this again. What is AQ? AQ will always have to be x root 3 over 3. That much I know for sure because that's just the way it goes. What is DQ going to be in that case? Oh, no, I mean, we know what DQ is. DQ is going to be the same exact thing because AD is going to be x. It's x squared minus x squared over 3, which is 2x squared over 3. Take the square root of that. That gives you x root 6 over 2. Over 3. Sorry, my bad. Over 3. DQ. So that's correct for DQ. What is DP going to be at any time? Right? DP is what we're... Now we want to equate the distances. So DP squared is going to equal PQ squared plus AQ squared because that gives you AP squared by the Pythagorean theorem. And PQ we know is we're calling that Y, aren't we? That's just Y. AQ we know what that is. DP. What is DP going to be? DP is going to be some amount minus Y. X root 6 over 3 minus Y. And when we actually square this stuff now that's where we have to check that our work is correct. What is PQ squared? That's Y squared. What is X over root 3 squared? X squared over 3. What is this? This is going to give you 2x squared over 3 for the reason that it's 6 over 9 x squared, which is 2/3 x squared. Yeah. Minus, now we multiply 2xy root 6 over 3, correct, plus y squared, correct again. Now we get x squared over 3. I don't know. Okay, wait. So this will be a little close, I think. Maybe you messed this step up. 2xy root 6 over 3. We're equating this with just x squared over 3. That goes away, and that goes away. That goes away, and that goes away. Y is equal to x over 2 root 6. We can multiply this nicely to get y is equal to x root 6 divided by 12. That's our PQ, right? That's our PQ. And that's our AQ. So it's x root 6 over 12 divided by x root 3 over 3. And this is nothing but x root 6 over 12 times 3 over x root 3. Cancel that out with this, which gives you root 2. Cancel, cancel, 4. Root 2 over 4. I mean, that's what I'm getting again. So, yeah, I mean, that's what I can think of. What is the ratio? I mean, did I misunderstand something? Oh, AQ over here is, so when they say AQ, because of the way they defined it, they're talking about DQ. DQ, which we know is x root 6 over 3, right? Right? And so it's x root 6 over 3 over that, which is also incorrect, it seems. So my next wager here would be that it is, okay, PQ is that doesn't change, over AQ. Yeah, because they're saying extend AP, so they're talking about DQ now. And DQ has to be root 6 over 3. What was PQ? Oh, wait. Wait. We solved for PQ and we got that to be x root 6 over 12. So it's x root 6 over 12 divided by what? No, sorry, PQ divided by DQ, which is x root 6 over 3, which is um 1/4. 1/4. I misread the question. I misunderstood what it was asking for. But the work there was correct. Okay, I mean, we've been working hard for about 2 hours. I want to pause it because it's getting late. I have to wish people good night and stuff. So I'll keep continuing it because I remember I started a little bit late. So I'll mute myself till then. Okay, I'm back now. Sorry about that. Yeah, I think I made up for the time now as well. So let's continue. Find GP plus GQ plus GR in this, given a few things. So given that AB is 3, AC is 5, and BC is 4. Okay, so it's a right triangle, obviously. The medians AD, BE, and CF intersect. Okay, so um, that's where they meet. Let the projections of G onto BC. So those are the altitudes, and then okay, and then we're asked to find that. Let's see. So like the data, there's a median is a bisector of a side. So I mean the ratio we know that BG would be 2/3 of BE, but I don't think that's really going to help us much over here, right? That's not going to be of too much use to us. There's a property about the medians though. I think there's some property about the medians of a right triangle, or maybe there isn't. But if there is one, I'm sure that could be of use here. But I'm sure there are enough ways to go about doing it without that as well. So let's see if we can't find something here. I understand like what it looks like, so I want to just draw it out now. This is 3, this is 4, and this is 5, and we have this point. Well, actually, wait. If this is the the location where you're, I think this is the case. Like it should look like this. And the way that I've drawn this length here, yeah, okay, that's what I'm getting. The reason that I say this is um, well, because, so, oh, wait, because it's a centroid, it's 2/3 of the way here, 2/3 of the way from this point. So actually, no, sorry, this should be 8/3. Okay, I guess it's just not drawn to scale then because something seems off about the way it's been drawn. But what, according to what I think, this, so, okay, this is what I think it should look like. Just based on the fact that it's a centroid, right? This is the center, right? G is the centroid. Yeah, the centroid is G. Because that's G, this is going to be 2/3 as much. So this is 8/3 and this is 2. Um, and from this, that already gives us two of the values that we need. We need GP, we need GR. We found those. That gives us 14/3 plus this this length over here. How do we find that length? I think at this point it's fine to just use the Pythagorean theorem for that. This is going to be no, that's the problem is that yeah, so this is 5 over 2. What is this distance here going to be? It's going to be 4/3 and 2 square root. I mean, use a distance formula. So that's 16 over 9 plus 4, which is 52 over 9. So that's going to give you 2 root 13 over 3. No, why did we do that? We don't need to do that. We need to do 52 over 9 minus 25 over 4. Does that even work out? 216. No, that way, that doesn't even make sense. 1 second. Yeah, that doesn't work. So, yeah, I mean, that is the centroid. So this should be, unless, um, hmm. Oh no, that's completely wrong. That's not, no, no, that's not how it works. Never mind. That doesn't even make sense. So just ignore these numbers. Sorry about that. Yeah, no, no, that's not, legitimate. Sorry about that. Anyway, yeah, let's just continue then. So, I mean, we can still probably figure it out because just by virtue of similar triangles, maybe. So these two are going to be similar, and then you're drawing this over here. All of these are 2/3 of the way to the other side. And I mean, we can probably use analytic geometry here. I know I haven't done that for a single question this far, but it's probably possible. It's just that I don't want to do it because it would take a long time. I also think that we can use the fact. Wait, so the centroid breaks it up into six triangles, each of which have equal area. So this is going to have the same area as this, which is going to have the same area as this. Okay. What's the area of the entire thing? The area of the entire thing is going to be 3 times 4 over 2, so 6. So each of these has an area of 2. This is 3, this is 4, this is 5. This is then going to be, so each of the product of the height and the width for each of them is 4. So this is going to be 1, this is going to be 4/3, and this is going to be 4/5 or something. Yeah, yep. And so they all multiply to 4. And so it's 4/5 plus 4/3 plus 1, 4/4. And that gives us a total of 12, 20, so 32 over 15 plus 15 over 15, which is 47 over 15. Yeah, okay, that's what they said as well. That's the solution too. Let's G be the centroid of ABC. That is the point where the segments are in each vertex are. If ABG is an equilateral, so that's a centroid, ABG, and that would look approximate. Yeah, no, not like that. It would look something like this, maybe. Yep, and none of those I'm realizing now actually look like. Yeah, it doesn't look like an equilateral triangle. But at the same time, if ABG is equilateral with AB equals 2, that tells us that this is 2 and this is 2, which means this is 3 and this is, well, no, okay, badly drawn. This is 1 and this is 1 and this is 2. Now, if this is the case, I think it's, yeah, compute the perimeter. Like, again, lots of, no, wait, we can figure this out. 2, 2, 2, because this is a special one because it's isosceles or whatever. This intersection is going to have, no, wait. 2, 2, 2, that's 60. So yeah, this is going to be root 3 in that case. which is actually enough to tell us about the triangle. If this is root 3, if this is 2, this area is going to be root 3. Yeah, I mean, this is going to be root 3, which means this is going to be 2 root 3. This is going to be 2 root 3. So it's 2 plus 4 root 3. No. Okay, compute the perimeter of ABC. What did we do wrong here? 2 times root 3, that's correct. If that's 1 and that's 1. I don't think, wait, maybe I've just actually done something wrong. Yeah, wait. They don't have to be, not only do they not have to be, they can't be perpendicular over there. So what I managed to figure out here is that the areas of these do have to be the same, but that's not enough to tell me what it actually is, if you know what I mean. We know that that's 3, we know that that's... Okay, so the other piece of information that we have then is that this is 2 root 3. And I think we now need to build off from there. So what we did in the before this, that does not work, obviously. So let's actually go ahead and get rid of this. Yeah, okay, I need to be a little more careful then. If this is 2 root 3, this is not 2 root 3, never mind. Um, we do know though that its area is going to be very neat. It's going to come out to be just root 3. If the area is going to come out to be root 3, how can we kind of make that happen? We can say that this height over here is root 3. And I think this will now really fix things for us. If this is root 3, right? If this is root 3, um, uh, this would have to be what? 3 halves? Okay, wait, this seems a little hand wavy, but we know that this part is still 1. We know that it's so 2, 3. What is that when you square it? Hmm? Well, I mean, okay, I guess if this is 2, 3, that's going to give 12, 9, 5. 2 root 3. Okay, wait, this seems weird. If this is 2 root 3 and this is root 3, shouldn't this entire thing just be 3? And if that's the case, doesn't that imply... Yeah, I mean, okay, no, so something is wrong here, obviously. I'm not sure what exactly it is, though. Must they all have the same area? They probably have to. At the same time, maybe you're forgetting something. Like, so if the triangle is equilateral, I mean, no, sorry. The triangle has to be isosceles because it seems symmetric to me. Okay, if this is 2 root 3 and this is root 3, let's answer the question. What will this be? This will just be 3, won't it? I mean, yeah, I mean, that will be 3. Only that that's not possible. Or is it? Is that possible? If that's 3, We know this part has to be true, but now it's like suddenly looking very weird because this should not at all be possible. That's still a right triangle, so maybe now what we can do is kind of the only other alternative I know I can think of to find the length is to use Heron's formula. And that's going to make it very messy, right? Like so what we would have then is um, times this minus 2, this minus 2 root 3, this minus x. That's not going to be neat at all. Actually, this could work. So we're going to call it 2x because it's going to make our work easier here. And so the first one is going to be 2 root 3 um, over 2 because you're subtracting off the 2x. But then we're also going to have chances to do stuff like, wait, no, sorry. So this is just equal to, I'm going to do it on top of here. This is 1 plus root 3 plus x. So one of them is now going to be 1 plus root 3 minus x times 1 minus root 3 plus x times root 3 plus x minus 1. And the reason I wanted to do this is because these two would now give us a nice difference of squares. 1 plus 3 squared minus x squared. And then over here we can probably do something similar. X is positive in both. So we can take it as, let's just evaluate this and see if we get anything. No, I mean, there has to be some trick, right? Yeah, so it's x plus 1 minus root 3 times x minus 1 minus root 3, isn't it? Minus 1 minus root 3. Yep. And so this is now x squared minus 1 minus root 3 squared. What does this give us? Um, because we're multiplying it, we can probably rewrite this as this is one of our terms, and the other one is now we can take it a negative and make this 1 minus root 3 squared minus x. Is there anything that we can do with this? No, it seems not. Yeah, I mean, I don't think there's anything we can do here because if we could make this like a perfect square, which it very nearly is actually, it's like very, very close to a perfect square. So is there no way at all that we can make it like that? What if we do, instead of grouping those together the way we have right now, we can also group them in some other way and then get something like x plus root 3 minus 1 times x plus root 3 plus 1. Or in some way just like switch it, and then that could probably make things okay. This is definitely not the way you're supposed to do it. There has to be some sort of easier, cleaner way. Let's draw it out once more quickly. See, ABC. So it's going to be some sort of isosceles triangle. I'm pretty sure of that. And now the centroid is going to be here. Let's start with drawing the isosceles triangle, the equilateral triangle. Um, and now extend this a little bit more, a little bit more. And yeah, I mean, now we've got the shape that we need. We now know as well that if this is 2, and this is 2, and this is 2, this over here is going to be what? Oh my, okay, wait. This is going to be, it's very, very stupid. 2, so this is going to be root 3. This is going to be 2 root 3. This entire height is going to be 3 root 3. 27 plus this, which is 31. So 2 root 31 plus 2. I think that's it, right? Because it's so 2, 1 root 3 because it's a 60 triangle. Root 3 times 3, 3 root 3. 3 root 3 squared is 3 times 3 times 3, which is 27. 27 plus 4, 31. So 2 square root of 31 plus 2. No? Hmm. What did I do wrong here? Compute the parameter. Oh, wait, yeah, okay, this is very stupid of me. This is just 1. This is not 2. This part is 1. The 2 is the entire thing there. Okay, very dumb mistake there. My bad. Yeah, very, very dumb. Okay, in triangle ABC, so we need to like get past this now, recover from this mistake. We're also almost done with the 3 hours. Like needless to say, we did not finish the 100 question goal, but maybe we did like 40 or something like that, maybe. And that's progress at least. AB is 11, AC is equal to 13, and BC is equal to 20. The medians AD, BE, and blah 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 intersect here for B. Find GP. Okay, intersect at the center G. Let P be the foot of the altitude. Fine, not doesn't seem that bad. So that's 1. A, let's label it off. A, B, and these are going to be our altitudes. Yeah, okay. Obviously not the best on altitudes. That's fine. A, B, C, D, E, F, and this is G, and then down here is B. Asking us for GP. So my guess would be that we find GD and PD, and then GD squared minus PD squared to the 1/2. BC is what? BC is 20. So this is going to be 10, and this over here is going to be 10. I have to be careful with how I do this stuff. What is that going to be? Okay, wait. So again, all of them have the same area, do they not? I think they do. They do have the same area, each of these triangles. So why don't we try to figure out the total area and then find P from that? And then once you find P, I think that'll make the rest of our work quite a bit easier as well. So yeah, let's do that. What would the area of this entire thing be using Heron's formula? 20 plus 13 is 33, 44, so 22. And yeah, I mean, I think it's going to work out well because you get an 11 here. Then you have 9, and then we have 2. So, well, this is actually very easy. It's 3 times 22, which is 66. 66 is the area, so 11 for each section. Wonderful. If it's 11 for each of the sixths of the triangle, well, let me check. Did I do this right? Yep, 66 divided by 6 is 11. If that's the case, we will need the product of the base and the height to be 22. So GP is going to be 2.2. And that's it. That's it. We don't need to find anything else. That's literally it, right? Yep, perfect. Okay, that was nice. Medians are drawn from point A and point B in this right triangle to divide them in half. The length of the median is 6. How many is it? This seems like very easy again. A, B, C. I run from point A and B in this right triangle to divide. So A and B, blah blah blah. The length of medians. Um, to divide BC in half. So this one over here will be what? This is 6, and then the other one is more than 6. It's 2 root 11. If it's 2 root 11, so okay, first of all, that's 6. This is going to be 2 over here. No, yeah, this does not seem that easy anymore. 2 root 11 over 3 would be over here. Maybe you can draw this anyway and just see where we now, like where we can get with this. Because I think there's something special about the medians of any triangle. I'm forgetting what exactly, but there is some property. Mm, yeah, I mean, there are a few triangles over here, but what do you do with them? That's the question. Oh, wait, I think I know this. I know this. I know this. This is 6. Okay, wait, have I have a good idea. It's like something to do with root 3 over 2 or something. This is 6, right? This is x, and then this is y over 2. So x squared plus y squared over 4 is equal to 36. But you also know that y and x over 2, y squared plus x squared over 4 is equal to this, which is 444, right? And so if you add these up, you get 10, because you get 5x squared over 4 equals 80. No, sorry, no. 320, 4x equals 8, right? No. You get x squared over plus y squared equals 64, so 8 is the answer. Yes, okay, yeah, I knew it. You just make the right triangles this time. I saw something and I mean, I had the idea of how to do it in my head. And I would have tried it, but I don't want to make dumb mistakes. It's like very late at night, so no need to risk all that. An isosceles trapezoid has legs of length 30 centimeters each, two diagonals, and the longer base is 50. So this is what it would look like to me. 30, 30. This is 50, this is 30, 30, and so this would be x over here. This would then be 50 minus 2x, and this would be, okay, running out of time now, but we're almost there. What else do we know? We know that the diagonal is going to be, um let's remove this. That's probably going to make it messy. We know that the diagonal is going to be 50 plus x. No, sorry. 50 minus just 1x, because it's like 50 is the entire thing, right? So, or you can think about it as 50 minus 2x plus x. So 50 minus 1x squared plus, let that be y over there. And the way I'm doing this, I'm making two variables, but I'm going to find a way to get x and y by themselves. Wait, no. Yeah, I mean, so we know x squared plus y squared is equal to 900, so 30 squared. From this, we will now find out that 50 squared minus 100x plus x squared plus y squared is equal to 40 squared. Now we're going to go ahead and subtract from both sides, which will give us 100x minus 50 squared is equal to this. Mm, we can divide everything by 100, which will give us just x minus 25 is equal to -7. So x is equal to what? 18. If that's the case, well, this makes it easy. X equals 18. 3, 4, 5. So this is 24. What is 24 times 68? 12. This is going to be 16 plus 24. So 40, 32, 2, 3, 6, 1, 16, 32. Okay, no. So a little bit rushed over there, I think. We know that x squared plus y squared is 30 squared. We know that 50 minus x whole squared plus 30 squared is 40. And then we try to solve it like this, which gives us 100x minus 50 squared is equal to 30 squared minus 40 squared, which is, did I get the -7 wrong? Okay, so when we divide by 100, that is permissible. We get x minus 5 squared, which is minus 25, is equal to 3 squared minus 4 squared. 3 squared is 9. 9 minus 16 is -7. If you add 25 to both sides, wait, let's just check. Does this satisfy everything? If you got 18 and 24, 3, 4, 5, 30, that works. 50, that's 32. 32 and 24 is again 3, 4, 5. So 24 is definitely the height. What is the trapezoid's area in square centimeters? Well, it's should be um maybe I did the math wrong. 16. 2 times 8 is 16. 4 times 6 is 24. 16, that checks out. 2, 3, 6, 1, 1, 6, 3, 2. The longer base is 50 centimeters. Okay, wait. That changes everything. So it'll be, wait, does it change anything? Um, no, actually, all that means is that it's not going to be 68, it's going to be 32 for the bottom. One of them is 18 and the other one is 18 plus 18, which is 36. Um, no, okay, yeah, so one of them is 15 and uh, one of them is 14. 14 and 50 are the lengths respectively. So it'll be 32. Yeah, very dumb mistake. 24 times 32, right? 6, 12, 12, 16, 0, 8, 8, 6, 7, 7, 6, 8. Okay, yeah, very dumb mistake there, but it's fine now. We're now almost out of time. Maybe you can do one more question. What I'm happy about is like the relative degree of accuracy that I've shown today. So I'm happy about that. AB is parallel to CD. The diagonal is A, so A, B, CD, CD like this. The area of ABE, what is E? The diagonals intersect at E. There should be some property here, right? It's going to be some multiple of 70. My guess right now is x equals 2. And actually, to prove that, what if we say, no, I think that ABE is 50, ADE is 20. So this is going to be 2/7. This is going to be 5/7. And so, based on that logic, shouldn't this also be 5/7? And this 2/7, which would mean that you would be 70 times 7 over 2, which is 35 times 7, which is 245. Yes, this seems accurate. Also, there's no time left, so 245 is my guess. Okay, it's wrong. Um, in trapezoid ABC, blah, 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 blah. So why does this happen then? Like, why is this the case that we have um yeah, there's no time. Let's just finish this last question off though. No, but I want to get it though. Like, let's think about it. What if we had something simpler like this maybe? ABE, right? And so yeah, I mean, I see the angle here again. What I don't know though is how does the height compare over here? Right? Like how would the height of AC be relative to AE and CE? And maybe there's a way to figure that out. There should be. Aren't the diagonals usually perpendicular? Is that not a... Well, how would that help us anyway? Well, we're gonna hold off on that because the time is up now. Let's take a look at profile. 953. Oh, that's terrible. Where did we start? I wrote it down somewhere. 918. So all we did achieve today was 953 minus 918. So 35 questions. So that's, I mean, I guess that's, and we spent at least half an hour, or I think probably more than that, maybe like 40 minutes on one question alone, which we ended up getting only by guessing. So I'm not happy about it. And it was a very easy question in the end. So I'm not happy about that. 35 questions is pretty bad. But if you look at this, I think geometry is now our number one. I don't know how they calculate all this, to be fair, but that's at least good. And if you look at the geometry section here, we're basically done with like almost everything now. Almost everything is mastered. Just finish off quadratics level 2. A lot of these are green as well. There's some analytic geometry, right triangle trigonometry, which probably isn't too difficult actually. Let's try one just for fun. Okay, it's right triangles, right? How hard can it be? Yeah. In right triangle ABC, A, no wait, ABC, 10, 24, so 5, 12, and this will be 26. If M is on AC such that BM is an altitude of ABC, then what is cosine of ABM? ABM. Cosine of ABM, well, that's just going to be this divided by this, which is 24 over that, which is 12 over 13. No, 12 over 13. Yeah, okay. The diagonals of rectangle PQRS intersect point X. Just like that. If PS is 6 and RS is 8, what is sine of P? So PXS. Wait. Sorry. What is sine of PXS? Interesting. Well, so this is 3, this is 4, and this is 5. Isn't it just sine of 2 theta is 2 sine theta cosine theta? And so that's going to be 3 over 5 times 4 over 5 times 2, which is 24 over 25. Yeah, now let's see the slicker way of doing it, because there should be one. What do they do? Did they like draw um hmm. Oh, I see what they did. They did something smarter. They did 5 and they drew a perpendicular with 6, and then yeah, okay, whatever, they did something. Sorry. Oh, they moved us back there. I guess we've mastered right triangle trigonometry. What about one of these basic ones, like spheres, perhaps? How many pairs of identical? So It should just be 8. Like I don't see why it wouldn't be 8 because it's you're just doubling the diameter, meaning you're doubling every dimension. So you're uh, increasing it by the volume is going to become 8 times as much. Okay, that's it. Fine, not bad. This one's probably not so easy. Assume that the length of the Earth's equator is exactly 25 what 1,100 miles, and that the Earth is a perfect sphere. The tower of Lena, Wisconsin. What is the number of miles in the circumference? Wait, by the length of the Earth's equator, what does that mean? That means that all the way around. Okay, exactly halfway between the equator and the North Pole. What is the number of miles in the circumference of the circle of the equator? Okay, so I mean they're just giving us a new radius thing here. So over here we can find the radius, and then we can also kind of find the new radius here. That's it, right? And so to do this, what do we need to do? Well, we need to probably figure out. Ooh, yeah, I mean, we know that this angle is 45. We know this angle is 45 degrees. And so if that's the case, won't this just be, let's call this radius. This is also radius, and this is radius root 2 over 2. And so if that's the case, right, if that's the case, it's going to be 25 times 25,100 times root 2 over 2. That should be it. And so if you do this in the nearest 100 miles, what do we get? It's going to be 251 times root 2 over 2. Right? Where's my calculator? I don't. I'll use my phone. Yeah, I mean, I think it should just be that 251 times the square root of 2 divided by 2. And yeah, I mean, that gives us a nice enough answer, rounded to the nearest 100 miles. So that's 17700. Yeah, I mean, that seems fine. Yeah, okay, I mean, that wasn't hard. It was just like kind of weird. Square ABCD has its center at 8 comma 8. So like let's draw this out, right? The top side of the square is horizontal. What? Okay, so it's not slanted, it's straight. The square is then dilated and a scale factor of 2. Has an area of 2 square units. So what does a dilation at the origin mean? That means everything is pushed out. What would the furthest point from the origin be? Like my first instinct is it'll be this one. Well, yeah, I mean, what else is it going to be? It has to be that one, doesn't it? So this would be 10 comma negative 6. That's the initial point. It's dilated, so it's 20 negative 12. And I think that's it. 20 negative 12. No. Okay, what could I have done wrong here? It's got an area of 4 square units. Oh, wait. Wait. So no. So that means that each side length is 2. So this is 8 comma negative 7. 8 comma negative 6. This would be then 9 comma negative, sorry, no, 9 comma negative 7. So 9 comma negative 8, I mean. Negative 9. God, what am I doing? 8 comma negative 9. 9 comma negative 9, 9 comma negative 8, 9 comma negative 7 times 2. So 18 comma negative 14. 18 comma negative 14. 18 comma negative 14. Is that correct? Is that correct? That seems right. No? Okay, wait, no, because the origin is obviously not there. The origin is here. This is the furthest point. Terrible. That's really stupid of me. Okay. Triangle ABC has these triangles referred to as yo. So y is equal to something of x. Um, so you got 2 comma negative 5, then you got 7 comma negative 10, and then you got negative 4 comma negative 8. When you move it, you're just getting shifted down. So it's going to be y equals something, right? Y equals something. Y equals what? What could you be reflecting it around? So 2 comma 3 is going to 2 comma negative 5. Okay. Where is negative 5 located? Negative 5 is located at, one second, what did I do? This is 2 comma 3, 7 comma 8. Let's draw it properly. So 2 comma 3 would be here, 7 comma 8 would be like here, negative 4 and 6 would be like here maybe. And where is our after image? I'll draw this in open circles. 2 and negative 5, 7 and negative 10. So 7 and negative 10 would be like here. And then let me guess, this would be like negative 5, negative 8. Okay, negative 8 right here. So what has happened here? You're going down by negative 1. Y equals negative 1 right here. Right here. Like right down the middle, right? Y equals negative. That should be right. Okay, finally. Yeah. How many of the letters have a horizontal line of symmetry? What? H C O S. No. H C O 3. That's all I can think of. I mean, unless I'm misunderstanding it. That is a very easy question. When point A is reflected, so when point A is reflected over the y-axis, it lands on point B. What is the sum of the 4 coordinate values of point A and B? So if it's x comma 6, it's going to go to x comma negative 6. So it's just going to add up to 2x then. No? Oh, I'm dumb. Over the y-axis, the y-axis is like this. So it's going to be x comma 6, negative x comma 6. So it's going to add up to 12. That's it. Yeah. What is the number of meters and the minimum distance a participant must run? Let's see, how would they run a minimum? How would they do a minimum? So like what you want is to find a point at which you have, yeah, I mean, you just set it up algebraically, right? You have terrible drawing. Let's just draw it out like this then. Timer is still going. Okay, wait. So yeah, I mean, we'll see. At least let's get to a good number of questions in total. So 300, and really I shouldn't even be doing this in the hundreds, right? But let's see. Yeah, I mean, you know, let's just make it once. 3, 5, and 12. And so, um, oh, I drew it wrong again. Never mind. Completely wrong. It's like this, something like this. Yeah, perfect. 3, 5, this is going to be x. This is then going to be 12 minus x. So 3 plus x squared plus, uh, you want to minimize it, right? What is the number of the minimum distance a person has to run? So that would just be 5 squared. No, wait, that's also, what am I doing? It's going to be a quadratic, and it's going to be, you just want to minimize the quadratic then, right? Yeah, okay, that's it, that's it. Then add two zeros at the end, I guess. So we have 9 plus that, 25, so that's 34 plus x squared plus another x squared plus 144 minus 24x is equal to 0. It's a quadratic which can be divided by 2. So x squared plus 17 plus 72 is 89. Yeah, I don't think there's any nice factorization here. Unless there's... No, I don't see anything here. 89 is prime. Anyway, so 12 plus minus the square root of 144. Yo, wait, this doesn't make sense. This is wrong then, I think. We're getting imaginary numbers here. Yeah, so obviously, wait, I started the quadratic wrong then, haven't I? 12 minus x, is that correct? Yeah. Those are my meters in the minimum distance. What's my most? Okay, yeah, so it's a square root of both of these. Yep. So that changes it then. 9 plus x squared. But we can actually see this is x squared minus 24x plus 169. And 169 is 13 squared, so that doesn't really help us. Okay, now we need to optimize this, set this equal to, take its derivative and set it equal to 0. Or you can just say that this is your distance and then, yeah, I mean, this is what we want to minimize, right? We want to minimize this. And so 144 plus 169 minus 24x. Yeah, so we want to now find the derivative of this and set it equal to 0. That's not going to be particularly easy either though, is it? No. Mm. Yeah, I mean, I don't want to do this, but so you're gonna have 2x divided by 2 times this, but I want to keep that out. 9 plus x squared plus what? Plus what? 2x minus 24 divided by this square root. So yeah, I mean, there should be a 2 here, there should be a 2 here, but those don't really matter in the grand scheme of things because it's equal to 0 anyway. And actually, we can make things even nicer on ourselves by, because so we get x times this square root. Negative, negative, because they're equal to 0, like that. And now I think we can square. Luckily for us, these should. Oh, wait, no, they don't. They work out pretty badly, actually. They're going to give us some sort of cubic. You don't know, there has to be a way to think this through logically, right? I mean, just like logically. Um, you would want to be running it in such a way that they're similar triangles, right? So perfectly similar triangles. I don't know what the mathematical rationale for that necessarily is, but I'm sure that's how it is. So you would do 3/8 and 5/8 of 1200. 3/8 of 1200 is what? 150, 450? What is 5/8 of that? 750. Yeah, I mean, I'm sure this is the right answer. I just don't know how to prove it, but that's fine. That's fine. What do we do now? We can take out a 50 from everything. Now we have 6 and 9. You know, we can take out more than 50 from everything we get. No, let's stick to 50. Mm, yeah, I mean, so then here we'll have a 6, here we'll have a 9. You're gonna get another 3, and then you get 2 and 6. No, so you, no, 2 and 3, so that's 3 root 13. And then here you can do the same thing with the 5, I believe. 55 root 13, so that's 8 root 13 equals 40 root 13. Ooh, that seems off. 40 root 13. That's nowhere near the number that we had. Uh, it should be at least 1200, and that does not seem to be the case here. Yeah, I mean, obviously, there's something wrong here then, right? Did we take out a, so taking out a 50 leaves you with 9 and 6, from where you can take out a 3 and get root 13. 150 root 13 seems legitimate. And add to that 5 root 13, so that's 4. Oh, 400 root 13. Okay, kind of stupid. 400 root 13. I mean, the amount of dumb mistakes I made like this does not bode well for any exam. But 400 root 13, for this, I think it's safe to use a calculator. 1442. Oh, they reflected it. Yeah, that makes sense. A parallelogram has three of its vertices. What is the possible difference between the greatest possible perimeter and the least possible perimeter of the parallelogram? So let's get a little graph. This is all that we've done today. It's not that much. Okay, so let's draw out a little sketch of where our axis is. Negative 1 comma 0, 2 comma 4, and 2 comma negative 4. So what are the different ways in which we can be situated? We can either have mm, what I don't get is what is the possible difference between the greatest possible perimeter and the least possible perimeter of the parallelogram? So in one of these we can have, right, and because this is the case, what we will do is take, okay, let's just draw out all possibilities, right? You can have this and this. So this will be one option. This is option A, option B, option C. Where is it? Where is option D? Yeah, should there be a fourth option? No, I mean, I don't think there is any other option here if you've got this and this. I think if there were another option, that would now be that would not be an option because it's like kind of a reflection of itself about the axis, I guess. I guess also because it's like actually let's draw something like this, right? If you had something like this, then you can have this one, you can have this one, you can have this one, and then where's the other one? Are there only three that you can have? Mm, I mean, it doesn't make sense. There should be a fourth one, shouldn't there? I don't know. Yeah, like I mean, I'm not going to figure it out until I figure that this part out. Well, let's at least do this. So this is three, four. So this is going to be five, five, and then this part is also five and five. It's not a parallelogram, but it should be. What about if you have a as wait, no, no, okay, so you add two of them and you subtract the other. That's what's going on, right? I think that's it. You add two of them and you subtract the other. And in the end, there are only three combinations of that you can have. You can have 2 minus 1 minus 2, which is negative 1. And that happens twice because you can have 2 minus 1 minus 2 or the other 2 minus 1 minus 2. Or you can have 2 minus 2 minus negative 1, which is 1. Those are your only three options, right? For what minus what. You can also have minus 1 minus 2 plus 2, but that won't change anything, will it? No, that's the same thing. Yeah. And then for the second quarter, yeah, I mean, so there are only going to be 3 points. This is 20. The other two, I think, are symmetric. They're exactly symmetric, perfectly symmetric, with the feature that, so this is going to be 5, and this is going to be 8 and 8, right? 8 and 8, why? Yeah, 8 and 8. So that's 26. So 26 and 20, the difference is 6. Yeah, yeah. Okay. The line, this line, crosses the x-axis at P and the y-axis at Q. Point D R comma S is on the line segment PQ. The area of POQ is 3 times the area of TOP. What is the value of R plus S? Well, I mean, yeah, we can figure this out, can't we? When y is equal to 0, what is x equal to? X would be equal to 12. Um, and when x is equal to 0, y is obviously going to be 9, so 0, comma 9. Is there anything wrong with this? I don't think so. 12, 390. Yeah, okay. If the area of POQ is 3 times the area of DOP, POQ, same base, just the different heights. So R is going to be 3. What is S going to be? So, S is going to be equal to 3. So 3 equals negative 3/4. X is R plus 9. And so negative 6 equals negative 3/4 R. Cancel, cancel, cancel. 2, 8, 8. 11. Ooh, uh, very nice. Next one. Triangle ABC finds some slope in the interceptor. Line 3 becomes here. Okay. 0, comma 8. 8, comma 0, and then 2, comma 0. Fine. You're cutting it in half. When you're doing that, what does that mean? What does that mean exactly? It means that you're going perpendicular to this, right? You're the perpendicular bisector, or cut the area of ABC in half. Well, no, you're just going through the midpoint of this essentially, which is going to be 4, comma 4, except you're passing through this. So what is the equation of the line going to be? Well, what's your slope? Your slope is going to be 2, right? Because you're going, so it's 2x plus what? 2x minus 4. As easy as that. Find the sum of the slope. So the slope is 2 and the y-intercept negative 4. So negative 2 should be the answer for this. Okay, perfect. We mastered analytic geometry level 1. Now it gets hard though, it seems. Also, it's been 3.5 hours now. 0, 0, 1, 2, 3, 3, 4, 0. Quadrilateral ABC is cut into 2 pieces. Line passing through A. Oh, this is same as the last question, except it's a tad bit harder. A lot harder. How do we do this? So we want to break it in such a way that it cuts the area in half. What's the area of this right now? Right, let's see. We should probably be able to calculate that with, like not too difficult. Shouldn't be too difficult because it's all like straight. 3 and 1, so this is 3 halves. Okay, wait, we've been given a clue. We know that it intersects CD somewhere, right? Oh, what am I doing? We do have to find that anyway. But what we know is that it's going to go like this. It's going to hit CD at some point, such that the base is still going to be 4. What is the height going to be? That's the question. We want the height to be equal to essentially. Okay, let's do it like this. So this is 1 and 2. So this area is 1. This is 1 to 4. So this is 3. This height is 2. This height is 3. So that is 2 plus 3 over 2 times 3. What is this? This is 1. This is a height of 3, 1. So plus 3 halves. 15 on the 9. So this is 10. So that's 5. And so it is 1 over. What does the height have to be? Oh no, we need to find the equation of this line and then only then can we actually figure it out, right? So we need to actually find that. Fine. Um, or in other words, we don't care about that. We care about at what point on CD is the height going to be equal to 1, right? That's all that we care. Actually, wait, let's check. It's not 1 anymore, right? It's 1.25 because so the total area A, B, and then let's call this E and F. So this part is 3 because you're going from 1 comma 2 to 4 comma 0. And so the height here is 2, this height here is 3, so that's 5 over 2. You're multiplying it by 3, so that gives you 15 over 2. This section over here is going to be 1 times 2 over 2, so that's 1. And then this last section over here is going to be, this is 1, that's 3, so it's 3 halves, which is 10. Yeah, that's correct. So this area is going to be 5. Because this length here is 4, this has to be 1.25. So y equals 1.25. What is the equation of this? It's got a negative 3 slope, I think. So y minus 0 equals negative 3 times x minus 4, meaning y is equal to negative 3x plus 12. And when is this going to be equal to 1.25? Mm, no, 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 no. Positive 43 over 12. Oops. Yeah, like that. Comma 5 over 4. Very messy, I think. How do you remove this? So 5, wait, no, no, 43 over 12. Yeah, I mean, it is a fraction. Passing through A, the significance of that is what? Wait, let's check this again. Is 43 over 12 between 3 and 4? It is, so that seems right at least. Oh, it should be 2.5. It should not be that. It should be 5 over 2. Oops. 5 over 2. So, what do we have now? And this also works, I believe. So, it should be 19 over 6 comma 5 over 2. That should be our answer now, I think. Very careless mistake here, I think. Okay. Oh, incorrect. Did I calculate the area wrong? Yeah, I think that's a mistake I made then. How badly did I draw it? I didn't draw it that badly. It was like close-ish. The equation of the line is correct. Okay, yeah, that's not enough. what is the sum of the values of k for which the area of the triangle is a minimum? There's one. Okay, wait, I have to do some work right now. It's late, but I have to finish. So I'm going to pause this. Let's quickly check on how many questions we finished. Oops. No, 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 no. Wait. Give me 1 second. Chat GPT open up for a second. I don't know how that happened. Let's open up Alcumus and see. Yeah, I think we're good now. Um, 966. We started at 18, I think. Okay, no, also first of all, yeah. So the geometry thing. Level 10 is less than level 11, so we're not actually that ahead. Like we're not like smashing any records in geometry. All the same, we are making good progress. Let's check this though. So 918. So we've still not even done 50 questions. So obviously, next in the future, we're not going to have this sort of live stream title about solving 100 questions because that's obviously not going to happen. Maybe we can settle for like a hundred, like 5 minutes per question, something like that. Maybe 50 questions in 4 hours. That's probably doable, right? Anyway, though, let's look at geometry now. I think we made some good progress. There are only two more there. Okay, so quadrilaterals level 2, and then inequalities in triangles, circle area, circumference, funky circle areas, and cones. That's what, 5 things that we have to do a little bit more in, and then 2 new sections, and then after that we've mastered all of geometry. Number theory, all done. Counting and probability, I think all done. Yeah. Algebra, it's a lot of stuff, so it's like hard to do that. Pre-algebra, same thing. It's like easy. So after this, I want to do intermediate algebra, where there's still a lot more that I haven't done. A lot of it is just read, and then pre-calculus. Again, like this stuff, a lot of this is kind of difficult for me. So, or like I haven't studied it yet, so for now it's not too easy. Um, but yeah, I think that's it. If you guys have watched this long, please consider giving a quick subscribe since it's been like 4 hours of work here. So I'd appreciate like a few just subscribe, and then you can you can follow along. We'll do more of this stuff as well. I plan on doing this like every weekend until AMC's, and then even after AMC's, I should be continuing this for like other stuff as well. So I will be doing this. Um, Probably not on school nights because it's like it gets late then. Also maybe not for as long as this in the future. I just had some extra time today. But yeah, like definitely do follow. I mean, subscribe if you want to see more of this sort of stuff, and then let me know if you have any other suggestions. I used to be quite an avid player of For the Win, which is basically like a quicker version of this, like easier questions, and they're more speed based. So you just have to do it as fast as you can. The only problem is that there's no one else who plays it, so it's usually very very few people, and then you can't get a fun game. And yeah, I mean that kind of that detracts from the fun. There's also Math Counts Trainer, but that's kind of like a more boring version of Alchemist where there's less stuff, and it has a very weird sound as well. So I don't know, like over here, for example, 4, 5, so it'll be 5, right? I think. But and that makes like the only thing that changes is the rating here, so that's kind of boring for me. I don't like doing that. But yeah, I mean, like if you have any other suggestions, definitely send them in the comments. Maybe not to this live stream because I don't know if I can check them later on. But like on a different video or on a post that I make, anything like that, you could just feel free to give your suggestions there, and I'll try to act on them because otherwise I kind of just do whatever I feel like, and like I'm always happy to change things and make them more useful for you guys as well. So thanks again for watching. A quick summary so we can look back on what we've done today. Quite a lot of stuff. It was all in geometry, which actually wasn't my intention initially because I'd already done some at home today. Like I'd been reading from the geometry book, so I was planning on doing other stuff. But I guess it was a good exercise in geometry, so hopefully you enjoyed that. especially if you're also studying for AMC 10, 12. Maybe you'll get a lot of the same questions when you do Alchemist, and then this way, hopefully, this can help you. But again, yeah, I mean, not to belabor the point, but if you stayed this long, if you're here now, please do subscribe. Um, because I'm trying to get to 500 subscribers soon. We're only at 430 right now, so do consider subscribing again. Thank you. I'll stall for like 2 more minutes so this can become a 4 hour long live stream, which will be like a record for me. Until then, if you have any questions or anything, please do put them in the chat and I'll address them.